So, sir, do I have your permission to start the webinar, please?
Please go ahead, madam.
Sure. Thank you, sir. Thank you. Good afternoon, Excellencies, representatives from ISA member countries, and all the stakeholders and experts who are joining us today in this webinar on grid integration of renewable energy from world over. Ladies and gentlemen, as you very well know, grid integration is the practice of developing efficient ways to deliver variable renewable energy to the grid. Good integration methods maximize the cost effectiveness of incorporating variable renewable energy into the power system while maintaining or increasing system stability and reliability. Today's webinar will bring the spotlight on this subject matter with experts representing the institutions from across the world, sharing their experiences and innovative approaches. For the kind information of the participants, the webinar is webcast live through ISA YouTube channel. The simultaneous interpretation facility is provided in French and Spanish language for this webinar. We request you to choose language of your convenience by clicking on the language option icons on your screens. The presentations being made during the webinar will be uploaded on the ISA website soon after the webinar concludes. I request all the speakers to kindly adhere to the time slots given to you so that the webinar is concluded in time. With this, we move forward, and without taking any time further, I would now request Director General International Solar Alliance, His Excellency Mr. Upendra Tripathi, to please present the opening remarks. Over to DG sir.
Thank you, Megha, honorable dignitaries and excellencies from ISA member countries, respected speakers. In fact, I find almost 8-9 speakers, including 50 Hz. When we went to Germany, we had visited this company. And they are giving all credit to Indian software engineers who actually developed the software to minimize the estimation and predictability of intermissions of the renewable power. And my fellow ISA colleagues and participants and delegates from other parts of the globe. I welcome you all to this important topic, grid integration. In fact, I remember in 2014 when I joined as the secretary in the Ministry of New and Renewable Energy, one of the key challenges they listed out was that you can't estimate how much wind energy you are going to get the next day, and how much solar to that matter. And more so, particularly in the rainy season, if you look at Tamil Nadu alone, they used to lose some 2 billion units of wind power because there was excess production. And it all depended on the monsoon and type of wind. So so there is a range of variability, and it was quite high. In some cases, you would estimate something for tomorrow, and it would either go excess by 25% or less than by 25%. Until we visited this this company in Germany, 50 Hz, and we are having some tea with the managing director, agencies, in this case the company. So that meant financial things. But what made us very happy is that the MD of 50 has explained to us how actually they used multiple IT software and technology to bring down this range of difference or unpredictability to a manageable range, almost to single figure. And then, of course, things started in Tamil Nadu and Gujarat, where the associations, both put in hardware and software. Well, that was 7 years back, and now things are much better. IT is more improved. And I'm sure when you talk about integration, this plays a very important role. And we do know that managing renewable energy depends on a few things, right? The size of the grid, when you have a provincial grid or a small country, it finds it difficult to manage the grid. But if you look at Europe, where all countries are, aggregated or integrated, it becomes much easier. So that is why, in the context of one sun, one world, one grid, when we are talking about a single grid supported by the World Solar Bank, and much better and much more efficient and much more sustainable. But without going to those mega ideas of World Solar Bank and one sun, one world, one grid, Today, we are concerned with the member country. And we, in fact, have told Ernst & Young, who prepares the report called Ease of Doing Solar in 2019, they prepared 2020, they prepared, which we are going to launch soon, which has been launched. We are going to upload it in the web with some suggestions that have come, we will incorporate. But the point is, if we look at we are looking at the investment ratio in our member countries as to if they're going to invest $1. Could you kind switch off your microphone, please?
Sure.
If they're going to invest, okay, I think that is if we are going to invest $1 in electricity generation, I'm told ideally, we have to invest $1.5 in grid. But if you look at this ratio, and we are going to look at this ratio in the ISA member countries, how much money they're investing in the power generation sector, both efficient capital for to meet the ideal ratio of investment and promote those areas. But to sum up, and I'm very happy today that the type of speakers we have got, starting from KFW, with whom we had multiple meetings to discuss about the green energy corridor and some 1.25 billion euros they have put in. We would like all ISA member countries or regions to have this type of green energy corridor. And soon that Germany will be a member of ISA, we are going to sit down with KFW and discuss how the Indian example of green energy experiences and expertise from one member country to the other, and that is the facilitative role we play. And I would also like to announce that two things we have taken up, and those are very important. We have decided to train 35,000 stakeholders under 7 programs, and 5,000 each. And not only that, under the project, the Solar Technology Application Resource Center, we will train 1,000 scientists from these centers. And we will also strengthen, to begin with, 10, but we have a target of 100 centers for which we have kept $200,000. And the 35,000, 5,000 per program, 7 programs. This training will not be limited to government officials. They will be all stakeholders. And I'm very happy, and I congratulate my colleagues and IRIDA, who actually financed the solar banking training. It has become very popular. And our webinars and seminars are becoming very popular. So even post-COVID, the virtual mode is going to stay. And we have discovered that this carbon-friendly mode is quite useful. And we are bringing in the new expertise and technologies to benefit our member countries. So I'm sure, not only the MTech program we have started, the MBA program is going to start. We are going to start a diploma undergraduate program with Kanpur IIT. And so with a whole lot of capacity building measures that we are getting, we look forward to a very bright and bright future, not only for ISA, but ISA is what all our member countries are. So with those words, I welcome you all once again. And I'm sure this webinar we will record, we will put it in the YouTube, we will put in our webpage. So for that, of course, I'm sure you will permit us to do so, because we believe that, the more we disseminate knowledge, the more it is going to help our member countries. Thank you once again, and welcome you all.
Thank you, DG sir. I now request Sri P.K. Mahapatra, Regional Coordinator for LAC Region and Advisor International Solar Alliance, to please set the context for today's webinar. Over to Mahapatra sir, please.
Thank you, Megha. Honorable Director General ISA, dignitaries and excellencies of various member countries, distinguished speakers of the webinar, my fellow ISA colleagues, and other participants. A very good morning, afternoon, evening, depending on where in the globe you are located. Honorable DG has already given a brief background of organizing this webinar. It's now my privilege to welcome you all once again to today's webinar on grid integration of renewable energy being organized by the ISA Secretariat. This webinar, as you are aware, is a part of the larger effort of ISA towards knowledge dissemination and capacity building for the ISA member countries. The objective of this webinar is to initiate fruitful dialogues between various stakeholders, including the technology suppliers and the member countries, so as to develop an actionable roadmap for integrating the variable renewable energy VRE sources with the electricity grid. Additionally, the aim of the webinar is also to generate new ideas and to take learnings from the established models to facilitate setting up of innovative projects across ISA member countries. As for the World Energy Outlook Report 2020 by the International Energy Agency, IEA, the COVID-19 pandemic caused more destruction to energy sector than any other event in the recent history, leaving impacts to be felt in the years to come. Global energy demand is expected to fall by 5% in 2020, energy investment dropping by 18%, oil demand falling by 8%, coal use falling by 8%. There is no single storyline. The global energy demand is likely to rebound to the pre-crisis level only in 2023 in the stated policy scenario. It may be delayed to 2025. Most vulnerable to be worst affected, reversing years of progress, number of people without electricity access in sub-Saharan area is set to rise. Renewable energy, however, grows rapidly as per the report in both the scenario, that is both the stated policy scenario and delayed recovery scenario. The report says solar becomes the new king of electricity, with solar at the center of the new constellation of electricity generation technology. Electricity grid could prove to be the weak link in the transformation of the power sector with implication of reliability and security for electricity supply. Coal demand does not return to pre-crisis level, and its share in 2040 energy mix falls below 20% for the first time since the Industrial Revolution. The era of growth in the global oil demand comes to an end in 10 years. Natural gas, however, fares better than other fossil fuels. Many countries across the globe have already started ambiguous targets to increase their renewable energy contribution to meet their domestic energy demands. According to the Sustainable Development Scenario put forward by the IEA, the share of renewable energy in the global energy mix is expected to increase sharply to be more than 30% by 2040. And among various renewable energy sources, solar and wind systems are experiencing growth since 2010. Over the next decade, India, Indonesia, Kenya, and the Philippines, among other nations, are aiming to add hundreds of gigawatts of new wind and solar capacity, most of which is likely to be interconnected to the electricity grid. Since solar and wind tend to be more variable and unpredictable than the conventional sources, improvement in power system planning and operations will be required to meet these targets. One of the important targets of the Sustainable Development Goal 7 states, and I quote, by 2030, expand infrastructure and upgrade technology for supplying modern and sustainable energy services for all in the developing countries, in particularly least developing countries, small island developing states, and landlocked developing countries, in accordance with their respective programs of support. The target outlined in SDG 7 ultimately means that countries have to be more mindful of the issues concerning integration of various renewable energy into their existing systems. This means establishing systems and processes for enhancing existing capacity, as well as to make the grid more flexible. As renewable energy becomes the mainstream, policies need to cover the integration of renewable into broader energy system and consider socio-economic impacts affecting the sustainability and pace of the transition without leaving anyone behind. The UN has also identified as one of the key levers for accelerating achievement of SDG 7. The grid integration of renewable energy is the practice of developing efficient ways to deliver variable renewable energy VRE to the grid. Robust integration methods maximizes the cost effectiveness of incorporating variable renewable energy into the power system while maintaining or increasing system stability and reliability. An important aspect of the power system planning is ensuring that adequate generation capacity exists to meet electricity demand during all hours of the years. Mechanical failures, planned maintenance, or lack of on-demand generating resources, especially for VRE resources, may leave a power system without sufficient capacity to meet the demand. According to the IEA survey, renewable energy has so far been the most resilient source of energy during COVID-19 lockdown measures. Although the demand has dropped for other renewable applications, the renewable electricity has been largely unaffected. Several countries, including Belgium, Italy, Germany, Hungary, and eastern parts of the United States, have seen record high hourly shares of variable renewables in electricity demand during the lockdowns. Overall, over the past year, the electricity network has been able to cope with rising proportion of variable renewable energy generation. The large-scale deployment of solar and wind generation has changed the paradigm of power systems and electricity markets in which prices were traditionally based on marginal generation cost and fuel prices. However, the lack of system flexibility has become a prominent concern with the rise of the share of VREs and distributed energy resources with simultaneous phasing out of the thermal plants. A well-integrated renewable energy system would allow not only unimpeded power flow, but also retain the stability of the system and the reliability. Network operators play an important role in this regard. While forecasting the tool and energy storage elements helps streamlining the injection of variable renewable energy to the grid, the demand side management, the demand response, active network devices like STATCOM and FACS, ancillary service market system, etc., play an equally important role in building a stable and reliable grid system. The grid integration challenges encompasses many elements. Key among them are: 1, new renewable energy generation plants in utility scale; 2, electricity distribution network; 3, integration of existing renewable energy mini grids; 4, construction of new transmission and distribution networks with provisions of dual flow of electricity; 5, increase of grid operational flexibility; and planning for high renewable energy penetration in future. These include issues related to power quality, forecasting power generation, cost of integration, availability of power, location of RE projects, and rate of variation of RE output. The distributed and dynamic nature of the renewable energy sources makes it highly challenging to develop a comprehensive plan to putting these aspects together. As a result, correct, complete, and up-to-date data and accurate analytical tools becomes as important to the energy ecosystem as the electrical system and equipment on the ground. Integrating distributed photovoltaic solar power results in unique benefit and challenges compared to the integration of utility scale wind and solar power. Significant localized growth in PV can raise concerns such as voltage variations and reverse power flow in a low voltage distribution system. However, various studies have shown that positive impact, for example, reduced line losses and avoided generation cost, can also result from distributed photovoltaics. Updating interconnection standards, procedures, and distribution planning and methodologies to better reflect the characteristics of the distributed photovoltaics can help realize these benefits and delay or even prevent the need for grid reinforcement. While addressing the grid integration of the variable renewable energy, it must be recalled that the common wisdom of 20 years ago among the most electricity companies and power engineers was that going beyond 5 to 15% share of variable or intermittent renewables such as wind and solar will doom the electricity grid's reliability. However, demand response and storage are now emerging as tools for increasing flexibility at a very high penetration of variable renewable energy. Stationary battery energy storage systems are used for smoothing the demand and supply around the power generated from variable renewable sources, and particularly renewables. It ensures that electricity is available even when generation from renewable is not available. In UK, battery installations are primarily being deployed to supply services to the national grid. Such ancillary services are increasingly important to meet supply and demand as growing amount of intermittent wind and solar power comes online. There is also the beginning of hybrid renewable energy plants, where batteries are installed alongside solar farms and wind farms and combination thereof. In other parts of the world, such as Australia, batteries are being used to make grid more resilient and avoid blackouts. With a comprehensive approach towards the variable renewable energy integration, the industry has the potential to break down yet another barrier and paving the way for a sustainable, low-emission future for the world. Today, in this webinar, we'll hear from industry representatives, including grid operators, power system planners, power market operators, financiers, and other agencies involved in grid integration-related projects. They will be highlighting the grid integration issues and also be sharing the global experience of grid integration. I'm confident that with such diverse perspective, we shall be able to learn about grid integration technology and the tools, established examples, and experience and benefit of the grid integration of the renewable energy for countries across the globe. With this, I would now like to invite the speakers for their presentations. Over to you, Megha.
Thank you very much, sir. Power Grid Corporation of India Limited is the central transmission utility of the host country, operating under Ministry of Power, Government of India. PGCIL is engaged in power transmission business with the responsibility for planning, implementation, operation and maintenance of interstate transmission system. Power Grid is also playing a major role in facilitating grid interconnection of renewable generation across the country through implementation of portion of ISTS part of green energy corridors, and is implementing the renewable energy management centers for managing the renewable generation, integration and operation, which shall include a host of activities from renewable energy forecasting to energy balancing and generation scheduling. I now invite Mr. Ashok Pal, CGM CTU Power Grid, to make their presentation on introduction of Indian power system, planning and impact of renewable integration into the grid. Over to Mr. Ashok Pal, please.
Okay. Thank you, madam. It will be better if you tell us the time, how much time should I get for this presentation?
Sir, you have 15 minutes for this, sir.
Okay. So let me share the screen. Is it visible?
Not yet, sir.
Okay. Now, is it visible?
Yes, sir.
Okay. So good afternoon, everyone. I'm Ashok Pal, Chief Channel Manager, CTU Power Grid Corporation. So this presentation contains a brief overview of Indian power system and grid integration of renewable energy. So I have few slides, so through which I'd like to explain. So this slide we got from IEA report, and which shows a very interesting figures of the worldwide installed capacity. If you see the present installed capacity as of 2020, coal 2000 gigawatt, gas 1800, wind and PV about 1400, hydro 1300. But see how it will be progressing over the years. So it's a huge jump for wind and PV, whereas the other sources are remaining more or less stable. Coal is slightly getting declined. So our main focus, worldwide focus, is for the wind and PV generation and its integration to the grid. So next is the Indian power scenario. We all know there are 5 regions and this total installed capacity is 375 gigawatt. And the peak demand now is around 190 gigawatt. We have again started growing after this lockdown. So at present, we have a renewable capacity of about 91 gigawatt out of 375 gigawatt. Now, if you see the transmission system, it's a huge network. These whatever we are showing is mainly comprising of ISTS line, interstate transmission system. So that's so many lines, and intrastate, if you combine, that will be huge. So most of these lines are in the ISTS, it is 765 kV, 400 kV, and the HVDC is also 800 kV and 500 kV HVDCs. And we have one nation, one grid, one frequency, and that is happening for a long time. And it's a single grid and one of the largest grid in the world. Availability of ISTS is around 99.83%. So it's quite a reliable grid. So new technologies which we are now dealing with, so includes the major things I have noted. One is hybrid substation, means earlier we went for AIS, then GIS, and now we are going for hybrid. There are fax devices, SBCs and STATCOMs, those to take care of the reactive power so that we can maintain the voltage in the grid. Then fault current limiters through series reactor. In the digital substation, we call process bus technology. Reconductoring of existing transmission corridors. HVDC system, and now it is VSC based HVDC system. Wide area measurement system, and National Transmission Asset Management Center, from which we control all the substations. So these are the new technologies. And now see where we are actually going. Presently, it is 375 gigawatt, out of which renewable is about 23%. And in terms of energy, it is about 12%. But in terms of megawatt, is 23%. And for 2025, if we go, then renewable, we are aiming at 39%. So it's quite a huge jump for the renewable for Indian context. Demand, we are aiming from presently 190 gigawatt to 267 gigawatt. Per capita consumption also from 1180 unit to 1600. So that is the projection. So if we focus on the renewable energy generation capacity, current capacity is about 91 gigawatt, and the generation energy generation wise, it is 10 billion unit, and we are aiming from 91, we are aiming to 175 gigawatt by 2020, and then 240 gigawatt by 2025. And then our ambition is to go to 450 gigawatt thereafter. So by 2022, we want to have a capacity penetration of 36%. Then we'll go to 39%. Energy penetration will also increase from 17% to 19%. So it's a big way we want to integrate the renewable projects. Now, the problems and how to balance it. So the basic main problem is the variability and the uncertainty. In the renewables, it is on the one hand, and the system, we need to bring the flexibility in the systems so as to balance these uncertainties. We need to have generation, more of hydro generation, more of storage, more of pump storage and other forms of storage. In the transmission also, to take care of the fluctuations, we need to have fax devices, STATCOMs, etc. We need to have smart grids. In the load sectors, we need to set up the load as per the renewable generation. So distribute the load accordingly, demand side management. So these are my tools to take care of the fluctuations and the uncertainty which will arise due to addition of so many renewable projects. Now, if we see that already our grid has a lot of flexibilities, generation flexibilities. If you see, we took a slide from there is a light off event on 5th April 2020. And there is a huge drop in demand in the night time. And if you can see the generations and see the blue portion, this is the hydro generation part. Hydro generation is there. So the hydro generation, the variability of hydro generation, that could take care of this huge change in the demand. So we have some hydro generation. We need to integrate more of the hydro generations, not only in India, but also to our neighboring countries like Nepal, Bhutan, which has huge hydro potentials. So those are will be extremely beneficial for integration of the renewables. Similar event, another event took place on 21st June 2020, where the solar eclipse took place. And if you can see the left side, the solar generation, you see there is a dip of 11 gigawatt that took place around 12 o'clock because of the eclipse. And to take care of the dip, we can see the variability of the green part. So that is all India hydro. You see the variations of that. And during the 12 o'clock, so we had that flexibility, that generation increased and took care of the deficiency of the solar generation during that time and managed the grid. But we'll be having more and more renewable, so there will be more and more variations, and so should be having more and more flexibilities to take care of these variations. So our issues are like this. These generations are short gestation period. In a very short time, those generations gets connected. Intermittent, variable, uncertain. So grid balancing, these are the issues we are dealing with. And how do we tackle? We are planning the system integration based on the potential. So based on potential, we plan the system and take up the system one after another in stages as the generation gets commissioned. Sometimes we go it beforehand also, because we started with green energy corridor. That is, before the generation comes, we started implementing the transmission system. So then the other flexibilities we have in generation transmission load, we have ancillary services regulation, we have primary response regulation. So that takes care of the reserves in the grid, which will take care of these variations. Then forecasting and scheduling, that REMC helps in forecasting and other management, and energy storage system, which is very important, and that is a large way to come. So initiatives which have already taken that includes green energy corridor, which we have just referred that we started implementing this corridor before the integration of the generation project, renewable generation project. After this green energy corridor, the second phase was the integration of ultra mega solar power parks. And along with that, we started implementing REMCs. So 11 number of REMCs has been installed and 2 are going to come. Then we have installed a lot of dynamic compensation STATCOMs and SBCs, more than 13,000 MVA to take care of the fluctuations in the voltage. And now what we are doing is the integration planning based on potential RE zones. So these potential RE zones, what we are doing is that we have identified 66.5 gigawatt in different states where the renewables are more. The breakup is given here, wind and solar wise. And phase wise, we have planned the system, and already implementation started, generations are getting commissioned, and lot of some parts are under bidding stage and some parts are yet to come. So these are taking up in stages based on the projects which are getting connected to the grid. So that is what we are planning within our country. But then also is the cross-border interconnections, which is very important, which I have referred just now. If we are already having the capacity with Nepal, Bhutan, Bangladesh, Myanmar, and Myanmar we are also planning. Sri Lanka is also, we are planning the link. Already we have capacity of 4,000 megawatt with these countries. Some are under construction and some are proposed and under various stages of approval. So all total 4,000 is existing and 4,000 megawatt, 4,500 megawatt capacity under construction, and future 7,600 covering all those neighboring countries. And out of that, it is useful to connect Nepal and Bhutan, which has huge hydro potentials and which will be really help in integration of the renewable projects. In regard to storage system, it is very much required to have storage. We are waiting for the technology to excel and to bring the storage at a lower cost, so that more and more storage can be applied. That would take care of this variability or intermittency, and that will also help in doing the economic operation, round the clock power. And some pilot projects, storage projects has been already installed. One of them is from Power Grid at Puducherry. This is how we are going ahead in technological interventions in different areas. Like in substations, we are going for digital, then automated, unmanned, remote control. In O&M, for O&M, we have already mentioned that NTMC, National Transmission Asset Management Center. Measurement and control, we have gone for SCADA, then smart meters, then WAMS, wide area measurement system. Power market, we have online power exchange, then RTM, real-time power market. So all these are measures towards handling the renewable projects. So, if we can then summarize, for renewable projects, no, this is some regulatory frameworks which we have already taken. Some regulatory framework which has taken that separate connectivity regulations has been found for renewable projects. Then waiver of the ISTS charges up to June 23, that has been done. Then there recently, this has been done by CRC, that their transmission components has been considered as a national component to be borne by everyone. Transmission components associated with the renewables. Then we have regulations for distributed generation resources. Then for incentivizing flexibility, means to take care of the renewable, the thermal PLF will bring down to 55% or even more. So that has to be taken care. In the ancillary services, reserve regulation ancillary services to take care of this variability, and then real-time power market. So these are the regulatory steps which has already been taken and more to come. So this is the last one. The way forward, basically, we should note that transmission infrastructure should match with the RE development. We should focus more on the flexibility and control in every front, in the generation side, transmission, load side. Ancillary services market, that is very much important to take care of the renewable variations. Energy storage, a big way to come to change our every concept. So the storage should come more. And then we need awareness, and one of the big steps is a seminar like this. We need awareness, we need capacity building. We have to focus on every funds to take care of this huge renewable integration in the coming time frame. So thank you so much. If you have anything, question, I'd be happy to answer that. So this is from my side.
Thank you, sir. Thank you very much for your presentation and for sharing PGCIL's vision for coming years and about RE expansion program of PGCIL. We also thank you for explaining variability and the measures to handle it in great detail. With this, I invite Ms. Saloni Sachdeva, Senior Program Manager, Renewable Energy, Shakti Sustainable Energy Foundation, to present an overview of grid integration issues at utility scale and for distributed solar and mini grids. Shakti Sustainable Energy Foundation seeks to facilitate India's transition to a cleaner energy future by aiding the design and implementation of policies that promote clean power, energy efficiency, sustainable urban transport, and climate action. Working collaboratively with policymakers, civil society, industry, think tanks, and academia, Shakti is working to catalyze transformative solutions to meet the energy needs in clean and sustainable ways. The floor is yours, Ms. Sachdeva.
Thank you so much, Megha. Could you please confirm if I'm audible?
Yes, please, you're audible.
Okay, I'll just share my screen once. Is my screen visible?
Yes, please, carry on.
Oh, perfect. So thank you so much, everyone, and a big good afternoon, good morning, and good evening to everyone present from across the globe. Wishing you all a very happy new year. It is my pleasure to be present here, and a big thank you to all the ISA members and the dignitaries there to give us this opportunity. I'll quickly start by my introduction. As Megha mentioned, I am Saloni Sachdeva, working as a Senior Program Manager, looking at the renewable energy portfolio at the Shakti Sustainable Energy Foundation. Today, I would be sharing my understanding and the learnings from the work Shakti has supported till date on renewable energy integration at the utility scale, distributed solar, and mini grids. I'll quickly start by saying that the Indian power sector is becoming an increasingly influential driver of trends in the global power market. And with our energy demand, which is set to double by 2040, and electricity demand, which is potentially to be tripling in the coming years, the journey we take now, the decisions we take now will be a game changer in the global energy market. We all are well aware of the fact that now, since the past decade, power sector is not just looked as a medium for economic growth. We look at power sector as a critical enabler for socio-economic growth and overall development of any country. Conversation around reliability, affordability, energy security, and sustainability have given birth to innovative policies, regulations, and business models. In the next slide, Yes, in this particular slide, I'll like to quickly give an overview of the power sector. India is now the third largest producer and consumer of electricity, with our installed capacity approximately 370 gigawatt as of September 2020, out of which the renewable energy share is 90 gigawatt. As India struggles to achieve a 175 gigawatt target, we have another huge milestone waiting for us, that is the 450 gigawatt. And there exist several concerns that need to be strengthened. On the generation side, the distribution sector, which has a huge potential, still needs tremendous uptake. Sorry, there was this comment. I'm just saying, is the presentation not visible?
It's visible.
Okay. So I'll continue with the huge RE penetration. Its integration to the grid opens up a Pandora's box of issues on the transmission side. Talking about the Green Energy Corridor, India's target was to construct approximately 9,700 circuit kilometers of intrastate transmission line by this December 2019, we were able to construct approximately 6,000 circuit kilometers. On the interstate transmission line, we have been able to construct approximately 3,068 circuit kilometers of interstate transmission line. As we all
put the full screen? Can you put it on full screen, please?
Yeah, I'll just do that. Is it better now?
Yes, thank you.
Okay. So in September 2019, the Prime Minister of India, Shri Narendra Modi, announced the 450 gigawatt target. We are very much confirmed that we will be able to achieve it. This is an emission target, but it requires a huge focus on unlocking the flexibility needed for effective system integration. This can be potentially be achieved by improving designs of renewable energy auctions, setting up a clear trajectory, and also understanding what are the different grid expansion and demand response strategies that India could take going forward. Coming on to the next slide. Yes. So in this slide, I like to talk about what is the value addition that high RE penetration brings to us. We all want to achieve an affordable, secure, and sustainable energy mix. And these four pillars or driving factors are the motivation factors for us. Specifically, robust demand, increasing investment and policy support, and competitive advantage. Under the demand, we have seen that to meet the 450 gigawatt target and in line with the increasing urbanization, electricity consumption is projected to reach approximately 15,000 terawatt hours by 2040. And this entire demand is almost mapped to two basic sectors, that is infrastructure and transport. And that was also very evident from the budget 2021 that was declared 2 days back. The RE would account for approximately 55% of the total installed park capacity by 2030. In the budget, there were two another highlights that I like to mention, giving rupees 100 crores to SECI and 1,500 crores to REDA to promote solar development. On the policy front, apart from the 450 gigawatt target, we also are focusing on the Atmanirbhar Bharat campaign, under which the PLI scheme worth rupees 4,500 crores for high efficient solar PV module manufacturing is allotted for the next 5 years. Coming on to the competitive advantage, I'm proud to announce that India ranked 7th on the EY Renewable Energy Country Attractiveness Index 2020, which was also mentioned earlier during the address. And India is one of the lowest capital cost per megawatt for pulverized coal power plants. And also now the per unit cost of solar is tremendously decreasing. In line with our INDC targets at Shakti, we strongly feel that investment in renewables can help drive India's future economic growth through innovation, job creation, resilience, disaster management, and obviously reduce air pollution. Coming on to the next, so in the next few slides, I'll specifically talk about grid integration issues at the utility scale, distributed and mini grids, starting with the large scale RE integration. So grid integration is a key need for scaling RE in India. And when we say integration, it is not just technical issue for grid management, but it also impacts the holistic economics of RE, economics of the renewable energy bringing into the grid. So this brings us to the question, what is the cost of RE integration? In the slides going forward, I'll talk about the technical policy and the regulatory aspects, but I look forward that during the discussion today by other panelists and the extreme experts present here, that we'll also dwell upon the cost of RE integration. Talking about different RE integration challenges, intermittency of RE sources, be it solar or wind, has been a long-standing challenge, which was also addressed by other speakers. We still have to efficiently and effectively forecast our solar radiation and the wind speed, and this has direct impacts upon the need of more flexibility into the system. We need more planned reserves, balancing portfolios, efficient power markets, demand response techniques, and energy storage technologies. India is also unique that we just do not face intermittency from the supply side. We also face demand side intermittency, owing to our 24/7 power for all targets and rural electrification targets. There's also a need for robust demand forecasting, and there exists historical data with the states, be it 10 to 15 years of SCADA data. But what is missing is a proper analysis and utilization of that data. So capacity building is required at the state level to use scientific measures for analyzing that data, and also to help them manage their peak properly with RE resources coming into the picture. I'll also like to mention about the inadequate injection and absorption of reactive power that comes into the system, which leads to challenges in maintaining the voltage, further leading to customer dissatisfaction and again cost implication on the power operators. Also, with more RE penetration, there's a huge impact on thermal power, which witnesses sudden ramping up and ramping down, as we are all aware of, and it stresses the thermal assets, leading to their long-term wear and tear. Possible solution for that is storage, and we have been nationally looking at the storage policy and coming up with new pilots around it. Another key area is the transmission network expansion and strengthening, and there is an immense need for the transmission grid reforms to be more resilient, flexible, and dynamic. The Central Electricity Authority's National Electricity Plan highlights the urgent need for more transmission line, and they have a target of 1.1 lakh circuit kilometers that will be required by 2024. So we can truly understand what kind of potential and targets we have. I'll quickly also talk about how the kind of research is needed at the transmission planning, pricing, and allocation side to understand what kind of state level transmission roadmaps are now needed going forward. All of these challenges that I now highlighted can come with research groups, international and global experts, academic institutions undertake the right kind of research and implement innovative solutions and business models. There's also an immense need to develop a structured wholesale market for better flexibility and RE integration, and I'm sure that will also be a point of discussion going forward. Moving on to the next slide. Number 7. Hello.
You're audible, please carry on.
Actually, I can't see that slide is visible or not. In my system, it is still stuck. Could you please confirm if slide number 7 is visible?
7 we can't make out.
Yeah, it's stuck, I think, on the hexagon that you have.
Yes. Just give me a minute. I'll stop sharing and reshare.
Sure.
Is it visible now?
Yes, please. I can see technical impact, solar PV integration on a distribution feeder.
Yes.
Sure.
Talk about and emphasize on the technical impacts that the distributed sites bring onto the power sector. We often call it as the little grid meeting the big grid. the inherent intermittency that we just talked about, which is due to the resource side variation and other power electronic based connection interfaces. So due to the variability of the solar radiation, the generation from a PV array is never constant. Hence, the grid-tied PV inverter injects a variable AC output, which is linked to the solar insolation, and it leads to voltage unbalance, sags, and overvoltage issues. As the previous speaker spoke about, when there's an instant of cloud cover or sudden solar radiation drop, as we just discussed, this could lead to sudden falling of the generation, and in turn a sudden stress on the distribution system, also allowing the need of flexible resources to jump in. Talking about the power quality issues, which arise from harmonic distortions, managing the peak load, intermittent solar rooftop generation, and improper forecasting and scheduling, all of these need to be focused on going forward. Proper power quality checks of components and system is required to ensure quality and durability of the systems. We are known that the Central Electricity Authority, which is the CEA, and the Ministry of New Renewable Energy, MNRE, has already specified design qualifications and quality standards for both crystalline silicon and the thin film modules, and there are proper testing guidelines, but still there are a number of faulty systems that exist on ground, and they are impacting the distribution grid. So proper monitoring and evaluation system and protocol have to be germinated and thought of. In case of past surplus utilities and excess generation from the solar rooftop, when it is sent back to the grid, it creates reverse flow into the distribution grid, and which has long-term impacts on the health of the distribution grid. Another key issue is phase balancing, which is an integration of distributed single phase grid connected solar rooftop PV. It comes in those situations. Lastly, talking about the anti-islanding feature of the solar rooftop, islanding refers to the condition in which the distributed solar system, where in the utility grid is not live, but the distributed grid is live. So it brings upon and health hazards to the workers who are working there, because once they're not aware about the fact that the solar rooftop lines are still live, it could have health impacts on them. So that is a key feature that has to be brought about. I'll quickly move to the next slide, which is the key policy and regulatory interventions. So on the policy and regulatory side, there's a need for clarity in the policy and regulations for increasing uptake of solar rooftop, and also what are the implementation guidelines, what could be the proper standardization frameworks, because there's a lack of standardization of process applications, such as what documents to be submitted for connection and application. All of these challenges have to be taken care of. On the technical side, we have still just discussed it, so I won't limit my focus on that. On the operation and administrative side, there is a specific issue on metering, billing, and collection. Lack of skilled manpower to undertake day-to-day operations brings on added burden on the DISCOM. A lot of the DISCOMs have pointed out in our studies that they have to take up additional task of solar rooftop monitoring and billing, and have expressed this as a concern. On the financial side, as we all know that...
Your slides are not there. Saloni, your slides are not visible.
Okay, there's some technical issue again. Again, the slides hang.
And sorry that, see the time also, please.
Yeah, I'm just closing another 1 minute. Yeah. Is this slide visible now?
Please carry on.
Yes. So I'll quickly jump on mini grids. As we know that mini grids have been an important component, and there have been certain studies and states coming up with their mini grid regulation, with UP, Bihar, Odisha, Jharkhand and Chhattisgarh coming up with their state level mini grid regulations and policies. But the question around how to integrate these mini grid with the utility grid still exists. Mini grid works in two modes. Either they work parallel to the grid, or they work in interconnection to the grid. When we talk about interconnection, there are certain guidelines that exist from CA as captured in the slide, but there still needs norms. There's still a gap of norms for standard technical specifications for interconnection of mini grids or at voltage level below 33 kV. As we all know that mini grids are of capacity ranging from 2 to 3 kilowatt to approximately 50 to 100 kilowatts. So they're usually interconnected at lower voltage, and technical specifications around that is something that is required. I'll quickly like to close with this last slide, which is the integrated power sector planning. We strongly believe that this is the way forward. We need to look at both at the load, demand, and the planning side together. Integrating planning with generation, transmission, and distribution could help us answer the question of optimal power mix for adequate, reliable service at the lowest system cost. And the central and state stakeholders have to work together to achieve this. I'll quickly like to close with a question for all of us to ponder upon. How can we build a system and processes that will yield desirable social, economic, and environmental outcomes, and could integrated power sector planning be the way forward? Thank you so much.
Thank you, Ms. Sachdeva. Thank you for sharing your learnings. And as you rightly said, power is an enabler for socioeconomic growth, and that is also from where we derive our mission. Of course, the issues with grid integration are huge, and solutions like storage and expansion of transmission lines are being assessed. We hope that with right kind of interventions, these challenges will be mitigated. Moving forward, Power System Operation Corporation Limited, ladies and gentlemen, is a wholly owned Government of India enterprise under the Ministry of Power. POSOCO is responsible to ensure the integrated operation of the grid in a reliable, efficient, and secure manner. It consists of 5 regional load dispatch centers and the National Load Dispatch Center. We have with us today Mr. A. Gracia, Executive Director, Southern Region Load Dispatch Center, POSOCO. I would invite Mr. Gracia to kindly make the presentation on role of Renewable Energy Management Center in RE integration. Over to Mr. Gracia, please.
Yeah, thanks, Megha. Can I share my screen, if you permit?
Sure, sir. Sure, sir.
Oh, yeah. You cannot start. You cannot start, it is telling. If you allow me.
So, Ms. Saloni, you can take off your presentation, please. It's still visible on the screen. Yes.
Yeah, okay.
Yeah. Thank you, sir.
Then how I'll go? I'll go to full screen. Okay. You are able to see me and hear me?
Yes, sir.
Yeah, thank you. Thank you, Megha, and good afternoon, good morning, good evening, wherever you are. I am Abhimanyu Garti. I am talking from Bangalore, India, and I will be talking of the role of Energy Management Center in the RE integrations. Yeah, I'll customize my speak as per the previous speakers. Whatever they have told, I'll skip. You are able to see my presentation fine?
Yes, sir. You can do it full screen, sir.
Full screen. Acha, full screen I'll do here. Yeah. Okay. 2-3 points I'll tell. Many of the things has been told. The 91 megawatt installed capacity in India has to go to 175, and again it has to go to 450. This is the government plan as initially told by chairman of this session during 2014. And 2-3 points are there. Now the entire India is almost a copper plate. Power can transfer from any place of the country to any place. The interregional capacity, transfer capacity is 100 gigawatt. There is a huge number. So from market point of view, there is no problem at all. And market already power exchange is in place, and anybody can sell the power anywhere in India. And the second, one more point I'll tell you that already my previous speaker has told. Now our consumption is around 4 billion units per day. That has to go to a very high level. It is coming less than 1200 units per capita in a year. There is a huge potential to go it up. Market is there. And how the REMC has come is that as per the large scale renewable integration plan by Government of India, they have a couple of points for the facility development. Many are there, transmission strengthening, already C2 has told. And the second point was the establishment of REMC. This is as per the government plan. And there are some other facility like dynamic reactive measurement, energy storage, and smart grid. Those has been told by other speaker. Then on the large scale renewable integration, some facility improvement, there has been some budget allocation and things like that. In there also REMC appears as 234 crore funded project. This will be not be tariff on the, there will be no border on the customers. It is a funded project by Government of India. Then if you come here, the present position, if you compare the Europe, USA and China, India's position is quite good. We are at the 8% penetration level in installed capacity. That is fairly good as compared to USA 10%, China 6.6 and Europe around 13 to 14%. And if you come to energy consumption per day, Southern region leads and Karnataka leads in that. 33% southern region daily consumption. If a southern region consume 100 MU per day, 33 MU comes from RE. That is a fairly good. And Karnataka comes 58 actually. 58% is very good. And in maximum demand, instantaneous value, demand type, Karnataka is very high, 91.4. Mostly more than 90% of the energy is coming from the RE. And in southern region 53. If you come to India, installed capacity 8%. Daily energy 14.5% and instantaneous value 20%. So 1/5 of the demand is made from the RE. That is a very good number. Because this good number of RE, that's why the REMC is required. So why REMC is the operation and integration of RE is different from this normal conventional generation. Conventional generation more focus on the stability and security of the grid, and they mainly depend on SCADA. The other two functions, which includes REMC, is scheduling, and the other one is forecasting. Forecasting and schedulings are done in normal SCADA, normal control center, but they are a different standalone machine and standalone software. Whereas in REMC, because of the inherent nature of job, it is integrated in the normal SCADA. So the REMC is slightly different than normal SCADA system, normal control center, in the form of number of tools available. The operational challenges already they have told, variability, intermittency, inertia, frequency, voltage controls are totally different. It has to be handled in a different manner. That's the reason REMC has been recommended. Different skill set, obviously, skill set when the requirement is different, skill set, the engineers are different, their expertise is different. The establishment is as per the global practice also. So as per the requirement, Government of India had appointed the Ernst & Young for the project and everything. All project has been completed and it is in operation. So this detail I will not go for the project. So this has been inaugurated by our MOSP, Sri R.K. Jain, on 28th February. And it has been done on a across the country, open through the video conferencing. So all the REMCs in India are in operation from February 28, 2020. So these are the REMCs. We have got National Load Dispatch Center, one REMC is there. 3 RLDCs, Southern region, Western region and Northern region. This is RE-rich region. Southern region major, 3 states are already there. In Telangana, we are LOA has been given by Power Grid. So it will be commissioned shortly. So Southern region 3 states, Western region 3 states, MP, Gujarat and Maharashtra, and Northern region Rajasthan. So these are the RE state 7 and Telangana added here. 8 states we have got REMC commission, and they are in operation other than Telangana. Then coming to capacity, we are now monitoring around 62,000 gigawatt of RE power is being monitored. This is in installed capacity. 62,514 megawatt of RE is being monitored by different REMCs. It starts from Northern region, NRLDC and Rajasthan, 9,000 10,000 you can take. Southern region 31,000. We have got SRLDC, I am sitting there. Karnataka, Tamil Nadu and Andhra Pradesh, total 31,000. And Western region we have got RLDC WR and 3 states, Maharashtra, Madhya Pradesh, Gujarat, total 21,800. Total is 62,500 is monitored through REMCs. As I told, we have got 3 function REMCs. We have got SCADA, that is normal SCADA we have got in conventional SLDCs and RLDCs. Then the forecasting tool in normal SCADA, normal SLDC is a different subject that is dealt by planning division. Similarly, scheduling is a different tool. It is also handled by a different department and different system, standalone system. So for in REMC, all the real-time monitoring, forecasting, and also scheduling integrated to a single system. That's why it is slightly different from the normal control center, load dispatch center, SLDCs, RLDCs, and NLDCs. All the it has been commissioned and COD has been done, and all are in operation, 1 year warranty and CCR AMC period. Here we'll talk a little on forecasting here, because this is the key. The REMC heart and soul is forecasting. As per the next slide, it will be there. Yeah, it is there. And REMC, you see, the forecasting is one of the major heart of the REMCs. So we have got internal forecasting engine, and there are 3 service providers who are giving a forecast at the pooling station level. So whatever pooling station, RE pooling stations are there, wind or solar, at RE pooling station level, forecasting is done both by internal module, that it has got its own logic and everything, and we can have a external input from the service provider. The contract is built such that the service provider will be providing, after 1 year experience, 1 person will go away. After 2nd year, 2nd person will go away, and 1 person will continue, whose results are better. And when it comes to the actual operation, the scheduling person has got the option to select anyone. He can select the best available through the service provider or through the internal logic available. So this forecasting tool is heart of the one of the major addition of the normal control room operation. It has got day ahead schedule, week ahead schedule, and intraday schedule is also there. Because as per the regulation, we have got the provision to allow them to revise the schedule 16 times in a day. Probably that will be discussed in detail in my next lecture when they will CRC will talk. So because there is a provision in the regulation, our RE people to optimize their cost, they have to revise. And because the system is variable, the RE generator is variable, they are allowed to revise the schedule and accordingly optimize their performance. If you see, first is wind and second one is solar. Solar is fairly, everybody knows sun will set at fixed time. So the prediction is fairly good. As per our estimate, it is very, very good. 2%, below 2% the accuracy rate. Other than this cloud movement, other things are very, very good. And we are developing some AI-based tool to based on the weather forecast, trying to optimize further in that. So solar is fairly manageable and forecast is accurate, but wind still remains really dependent upon the weather god. How they behave, we don't know. But if you see here, this is a different day forecast. So there is a variation between forecast and the actual. There is a variation. Yellow one and the green one is the actual. So still some work has to be done on the weather side, wind side. If you see here, this is solar, fairly good, because sunrise and sunset time is fixed, and generally the radiation level is predictable, and people are able to accurately manage the solar system. So at the same time, because solar is predictable, but there are inherent challenge. For example, southern region, we meet a demand of around 15,000. We meet a solar generation 15,000 megawatt. So 7 to 9 o'clock, 15,000 will be added, and evening 5 to 6 o'clock, 15,000 will go away. There is a huge challenge for the system, states and region to manage. Out of the 50 megawatt demand in southern region, 15,000 comes from the solar alone. Plus today, for example, today good wind is there, not a wind season, but still today we have seen 3,500 megawatt wind. So that really pose a challenge for the system to manage the variability and the reserves mainly. Then these are all the scheduling. We have got a very good system that whoever done some revision, there is a monitoring system. The UI is very, very good. User interface is very good in the REMC system. And these are the forecast, how it is trended. Forecast is there and actually is trended, and based on the trend, they can take the initiative of revising the schedule so that they will optimize their cost and their revenue also. And the difference between real time and REMC, small difference I have given here. Normal SCADA normally operates up to 110 kV level only. As I told, when the Unified Load Dispatch Scheme was commissioned in 2000 by World Bank project, that time there was a philosophy how to measure, what to be monitored for the grid monitoring. It was limited to 110 kV and above, because mainly for normal SCADA, mainly for the security monitoring of the system. Whereas REMC, the injection level is only 33 kV level, 11 kV and maximum 66 kV. Those monitoring needs a special measurement system, metering system. So that's why this REMC's metering system are special slightly. So their measurement is done in 33 and 11 kV level. And those parameters are there, analog and digital are there. There is not much difference here between our normal SCADA and REMC. The only thing here, voltage level is low. And the additional parameter we are monitoring is weather parameter. So every place, every pooling station, we have got a weather stations, and they monitor all weather parameter, but they will be only building a history. But the requirement for the operation is forecast. So forecast is the key, and still we depend on the BBC and other people for the weather forecast. And BBC and of course Indian Meteorological Department. All those parameters we are using for the forecast of the weather, and accordingly they are forecasting the wind and solar for the operational purpose. Then coming here again, role of REMC, there may be small repetition. A dedicated REMC team has been commissioned in all states. This is a good development. Earlier it was part of the RE were handled part of the SLDCs and RLDC, but nowadays we have a dedicated team everywhere. They are expert in their field, and we are giving proper training and expertise. Initial chairman was talking of the training, so I was very happy that special training has been organized by Government of India. There is a welcome step, because unless you are expert, you cannot, you will manage, just so will go on. But unless people are expert and they are in the, like expert in their field, they will not be able to do proper value addition. Data acquisition and forecasting and scheduling is special in the REMC, and day ahead and week forecasting is done. Single source, the REMC purpose is all the RE data, single source will be there. And it works as data repository. That means for every REMC, whatever you want, will be able to provide latitude, longitude, the RE supplier, the capacity, type of machine, everything is available in our REMC database. Then we'll go to next content. So this will be, REMC will do its own job. Plus in addition, it will be able to advise the normal load dispatching scheme. How for day ahead unit commitment is the major change, major problem nowadays we will face. In future also we will face, because reserve is a requirement. When the solar will come to 3,000, what is that? Now it is now 300 gigawatt. Now we have got, let us say solar is 100 gigawatt target in 175. When solar will be 300 gigawatt, and if you generate around 70% PLF, 200 gigawatt, it will be huge, because solar will 200 will come between 7 to 9 and it will go out at between 4 to 6 in the evening. So that amount of power has to be managed. All the load generation has to be made properly. So further reserve is required. For that unit commitment will be required for the conventional thermal generator and other generator, hydro generator. So this is advice by REMC to the other load dispatching scheme. It will be necessary. Now also we are doing in a phase manner. And CRC having we have given a proposal for the reserve ancillary service, RRAS. To arrive at day ahead balancing of the state for tomorrow, how they will be balance their needs, load generation balance and portfolio management, and surplus and deficit they can manage and sell the extra power in the real-time market. Real-time market is good now. I see daily in Bangalore, people are having more solar. Sometimes I see 2,000 megawatts sell by some people at 12 o'clock, 11 o'clock. They are taking the advantage of real-time market. Reserve requirement, computing the transfer capacity and managing the HVDC line flow. These are the advice REMC can give to the conventional load dispatching scheme. Then there are some challenges ahead for the huge RE integration. Though RE integration is necessary for our energy security, when already our previous speaker has told, the fossil fuel will go out and oil also will go out. The only source will be probably RE in future, maybe few decades down the line. Everything will not be there, so only RE will be there. There will be challenges. Weather information accurately availability will be one of the major requirements. The more accurate weather we get for tomorrow, the more easy will be for managing the RE, and more accurate will be the forecast. Real-time telemetry accuracy, now still there are inconsistency, and it will be wise to say that still because the private people, those who are small, they are having small plant, 50 megawatt or around that, they don't understand the accuracy, importance of accurate telemetry, which is very much essential for the monitoring and control of the system. That needs to be improved further. Fully automatic forecasting with using artificial intelligence. We are working on this. Cloud cover. See, cloud movement also prediction. People are working on all these things. The more accurate data we get, the more better forecasting and more better will be the operation. Some ongoing project work I have told. We are working with IIT Chennai and also Niue, in-house development of forecasting tools with artificial and neural networks, weather data analysis and finding specific pattern. All the work, everywhere people are working, including our team also working. Error analysis is being done. Consistent follow-up with the field and prediction of telemetry is being done. Yeah, that's all I'll tell from my side. If any question, I'll be happy to answer. Over to you, Mr. Megha.
Thank you, Mr. Gatia. Thank you very much for sharing all the details on role of REMC in RE integration. Thank you very much. With this, we move on to our next speaker. Our next speaker is Dr. S.K. Chatterjee, Chief Regulatory Affairs, CERC. The Commission for Electricity Regulatory Commission, CERC, intends to promote competition, efficiency, and economy in bulk power markets, improve the quality of supply, and promote investments, and advise governments on the removal of institutional barriers to bridge the demand-supply gap, and thus foster the interest of consumers. Mr. Chatterjee will highlight the policy and regulatory aspects related to grid integration. Over to Dr. S.K. Chatterjee, Chief Regulatory Affairs, CERC, please.
Thank you. Just to confirm if I am audible and if you could see my presentation.
Yes, sir, you're audible. We can see your presentation. I request you to put it on full screen, please.
Yeah. Thanks. Good afternoon, good morning, and good evening to everybody. And thanks to ISA and also especially to Dr. Tripathi for inviting me for this session. A brief presentation. I'll try and honor the time limit given to me, and I'll briefly touch upon the initiatives, especially the regulatory initiatives on RE integration here in India. This is a very standard slide which we have been using, and we saw in the earlier slides as well. We have about 91 gigawatt of renewable as of now, out of which a major share is of the wind and solar, which is intermittent. The basic intent of this slide is to show that here in India, we have been following a coordinated approach to policy and regulation for RE development. In fact, the journey that is depicted here gives you a brief overview of the various kinds of policy and regulatory. Policy has been the domain of the Government of India, and the regulation the domain of the regulators. So it's a coordinated approach of the government as well as of the regulator in making sure that the ambitious target that we set for ourselves is achieved. And given the context of discussion, and also given the fact that we have put special emphasis on the variable renewable energy like wind and solar in the target that we have set for ourselves, grid integration of renewable is a major challenge. But before I dwell on the grid integration initiatives that we have taken and what is the way forward, briefly talking about the regulatory interventions per se on the renewable landscape. We have a robust kind of a legal framework that exists in the Electricity Act of 2003, which provide for a framework for regulatory renewable purchase obligation, which in fact creates the demand side, gives demand side certainty for the renewable energy projects. We also have a feed-in tariff kind of a concept, which seeks to ensure the supply side certainty for the renewable energy generators. So we have both from demand as well as supply side certainty in terms of regulatory framework. We also have been talking about the market instruments to support the renewable energy segment. And in this whole context, once you have given the demand side support or the supply side support, or created an enabling market framework, ultimately need to recognize the basic nature and characteristics of the variable RE, which is the intermittency, and then take necessary actions in terms of integration of these variable resources. So coming on to the main topic of discussion today in terms of the integration efforts, especially the regulatory initiatives that we have taken. These are the four broad heads or the contours on which the regulatory initiatives are woven. First strand is the forecasting scheduling framework. Second, the flexibility framework, reserves and ancillary services. And fourth, which is critically important and possibly a way forward, is the enabling market framework. So our regulatory initiatives are centered around these four broad pillars. And we intend to strengthen all these pillars as we go along, because we have a huge target to meet, 175 in the interregnum and still higher. So now what is it that we have done so far in terms of the initiatives on these four pillars? I would try and briefly explain that. I mean, first important thing is the forecasting and scheduling framework. Now, the major objective, this was a big challenge for a regulator in India, at least 5 to 6 years back, when we introduced this concept of forecasting and scheduling. There was a big resistance from the wind and solar generators that we are intermittent, we are variable, we cannot be subjected to forecasting and scheduling, and also consequently the deviation settlement charge, or what we call here in India the unscheduled interchange charge. So the stand that we took as regulators is that you need to bring the RE generators in alignment with the existing framework of, or in terms of the discipline of forecasting and scheduling, but give them special dispensation, recognizing the special nature of their output. So that was a big journey which we started about 5 to 6 years back, when we created this framework of the forecasting and scheduling, and we brought the RE generators into this fold. But then we also recognized the fact that they are not the same as the conventional generators, so they need some special dispensation. But in fact, when we carved out a special dispensation for them in terms of the deviation, the error that they give. So for instance, we did some empirical study, and then based on the empirical study, we created a tolerance band. We said that, well, you have to do forecasting, you have to also give schedule, but then you will have the flexibility of revising your schedule 16 times during the day. And at the same time, if you are deviating from the schedule that you have given, you will have a tolerance band or no penalty zone within a band of plus minus 15%. And the definition of the error, the absolute error was also changed to suit the variability of the renewable. So these were the three important things which we did when we brought in this concept of forecasting, scheduling, and deviation settlement. And this was, as I said, the plus minus 15%, the tolerance band, no penalty zone, was based on the empirical study. And subsequently, I mean, we looked at the data from some states. This is only a snapshot of one state, which we were trying to gather information from. For instance, Gujarat, August to December 2019. So we have been. I think there is a voice. Yeah. So in Gujarat, we found, and there are instances in other parts of the country where we find that this tolerance band that we have given is adequate enough, and it's not really causing a lot of hardship to the wind and solar generators to the extent it was made out at that point of time. On the special dispensation, another critically important thing that we have done so far, and which is what we consider as an enabler for RE integration, is the concept of aggregator, or what we call here in India is the qualified coordinating agency. So we have brought about a regulatory framework of pooling the generation sources into a pooling station. So we have recognized the concept of a pooling station where the generation or the intermittency of the generators located in that particular pooling station can be pooled, and then this will also, the moment this is largely towards creating a larger balancing area. So the larger the balancing area, the less the impact of error, and it's good from both the RE generators point of view as well as from system operators point of view. So we have created this framework of aggregator concept. Pooling station is already recognized, but in some states, pooling of pooling stations is also being talked about, and we already heard about the REMC, which is also a good step towards aggregation of the variability. So these are some of these special dispensations which we carved out, but then we insisted on the need for forecasting and scheduling, because this is something which we considered as regulators are critically important to, get the buy-in of the distribution companies, who in fact quite often feel that they are bearing the brunt of the variability of the wind and solar. Coming on to flexibility, this was already referred to by previous speakers, but then this was also another intervention from the regulator's side. We tried to induce flexibility in thermal fleet. We brought in this concept of technical minimum of 55% for central generating stations with suitable compensation. This was considered necessary to, respond to the needs of variability or the challenges thrown by the variability of the wind and solar, or for that matter, demand. So a thermal generating station could be brought down to a technical minimum of 55% with suitable compensation to them. Then we also brought in this concept of, incentive and disincentive linked to ramping capabilities. Our tariff regulations, which have been issued only in 2019, they create a incentive and disincentive framework linked to the ramping rates. So basically, the intent is to encourage the existing thermal fleet to provide adequate ramping capability. Then we also brought in this concept of peak and off-peak tariff. All these things, in fact, are aimed at bringing in the desired flexibility in the power system operation, so that the integration becomes smooth and easy. Then we have, all that I'm talking about so far is basically the initiative at the central level here in India, but we are a federal country, largely, we have so many states. So we feel that unless a complementary market mechanism is, or complementary regulatory framework is created at the state level, you cannot really bring in seamless integration of the renewable. So we, as central regulator, we wear another hat of chairing the forum of regulators, which consists of all state commissions. So we have been cajoling and persuading the states also to come on board on the kind of initiatives that we have been taking at the central level here. Then the important thing that, of course, was alluded earlier was in terms of the reserves and ancillary services. This is one thing which we as regulators have recognized the urgent need for. So this is the broad framework of or vision of ancillary services framework that we have in mind. We have mandated primary response for the generators. And this slide gives you an overview. I mean, we have said that, no generating station can schedule power more than 100% of the installed capacity, which means that you have some overhead capacity which is available. That means you have even a thermal generator can go up to 105% of the installed capacity. So in a way, that extra 5% or 10% that is possible in terms of generation is available as primary reserves with the system operator, which it can use or which is used automatically. Then comes to secondary response. This was something which was missing in the Indian power system. And we realized that, and we in fact the Central Commission ordered pilots of AGC, and now but then we also introduced this concept of tertiary reserves, which is in the form of a regulation which was referred to earlier. We have formulated regulations on the reserves ancillary services, which is nothing but a tertiary reserves services. But then going forward, we are thinking in terms of a market-based procurement of ancillary services, which will seek to address, I mean, especially on the tertiary side, we are seriously thinking in terms of market-based procurement of ancillary services as we go along. This was way back in 2015 when the Commission passed an order directing maintenance of reserves at the national level, both primary, secondary, as well as tertiary, region-wise and state level-wise. And as I said, that going forward, we are wanting to. Another important thing, the last important point, which is really very important, apart from the forecasting, scheduling, flexibility requirement, and also the reserves and ancillary services, is the enabling market framework, which we believe is also another instrument for RE integration. We have already created, you would have heard by this time a number of times, references of real-time market. It's a half-hourly market, which has been introduced in June, from June of 2020. In the midst of COVID pandemic, we introduced this this framework of real-time market, which is a half-hourly market. So it's so close to real-time, and it's an ideal avenue and an alternate avenue for balancing renewable RE variability. We are expecting that gradually, since, as I mentioned, that RE generators have been given the flexibility of revising the schedule 16 times during the day. So 1.5 hours virtually. So you know that at least you have the flexibility of revising your schedule. That means at least 1.5 hours before the actual time of delivery, you should be in a position to forecast and schedule properly. If you are able to do that, real-time market is an ideal platform for you to get into and make revenues out of it. Not only that, in fact, here in India, the way the contracting is structured, the distribution companies have entered into long-term power purchase agreement with the renewable RE generators. So virtually the RE generation is owned by the distribution companies. So what we have been insisting is that, in fact, as portfolio managers, the distribution companies can also come and participate heavily in the real-time market and balance their portfolio of variability of the renewable energy. So we see this as a great enabler. And apart from the renewable energy, you have another discussion paper which we have floated, which is what we consider as a big game changer, but a big way forward. A lot of debate is happening around this concept now. We call it the market-based economic dispatch. It's more like a national merit order or centralized kind of a dispatch with adequate flexibility to the distribution companies to do self-scheduling. Basic intent is to reduce system costs and dispatch the generations based on the national level merit order. But we also feel that this is also going to be an ideal platform for renewable energy. How? This how we have, this is the last couple of bullets, which are critically important, and a vision. It is still in the form of a discussion paper, but we believe that if you have a robust kind of a market system, this market itself can guarantee must-run status for renewable. Because, you know, most of the renewables, especially wind and solar, they have low short-run marginal cost. So if you have zero marginal cost, short-run marginal cost, if you participate in the market, you definitely get a guarantee of dispatch. So you don't need to clamor for or ask for a regulatory dispensation in terms of a must-run status. If you can create a robust kind of a market platform, must-run can be guaranteed by the market itself. But then it remains the fact that they are variable. So if they are to participate in the day-ahead market, the question that comes, how do they take care of the variability closer to real time? So the answer again is in terms of the real-time market. So a RE generator participating in the day-ahead market can correct its position in the real-time market. And so again, you don't need crutches. You don't need a lot of regulatory support. So if you have a robust and seamless continuous market from the day-ahead market to the real-time market, the balancing requirement can also be addressed through judicious use of the day-ahead market in the real time. And also, as I said, DISCOMs can participate as portfolio players to balance their RE. This is a vision. As I said, we have not created this framework of market-based economic dispatch as yet, but we have come up with a discussion paper around that. But going forward, a lot can be solved through this mechanism is what my personal belief is. So in terms of the way forward, what is it that we have in our agenda as we go along as regulators? As I said, larger scheduling and balancing area is basically the need of the hour is what we have recognized, while at the same time making sure that the RE generators also do forecasting and scheduling. So we have created this framework at the national level. We have been engaging with the states through the state regulators to make sure that we have the larger balancing area through qualified coordinating agency aggregator. REMC also is going to play a major role in this whole process. And as I said, in a big way, market as enablers for RE integration is also another big agenda that we have arrogated to ourselves as we go along. Ancillary services regulations, well recognized by earlier speakers as well. We are thinking in terms of creating a robust market-based procurement of ancillary services, especially at least the tertiary part quickly. Another critically important element is the resource adequacy framework, which is also what we have been working on, because resource adequacy is something which is critically important to do proper power procurement planning. So these are some of the big agenda items that we have for ourselves as we go along in terms of integrating the renewable. Thanks for your patience and hearing. For any query, I am available to email on the. Thanks a lot, and over to you, Lisa.
Thank you, sir. Thank you for your presentation. Moving forward, we have with us today Dr. Jenny Rees, a Principal Australian Energy Market Operator, AEMO. The Australian Energy Market Operator performs an array of gas and electricity market operational, development and planning functions. It manages the national electricity market and wholesale electricity market and the Victorian gas transmission network. It is additionally responsible for national transmission planning for electricity and the establishment of a short-term trading market for gas. With this, I would like to invite Dr. Rees to make the presentation on distributed energy resource integration. Over to Dr. Jenny Rees, please.
Hi, everyone. Just confirming my screen's come up and you can hear me properly?
Yes, please. Carry on.
Wonderful. Okay, so my name is Dr. Jenny Rees. I work at the Australian Energy Market Operator. We're the grid operator for the major grids in Australia. So we run the national electricity market on the east coast of Australia and also the wholesale electricity market on the west coast of Australia. This presentation is about some of the work that we've been doing on the integration of distributed energy resources, DER, particularly distributed PV. We have a very large amount of small-scale photovoltaics in our grid, particularly in the South Australian region of our grid, which, if I go back to the previous slide, is this part of the grid down here. The South Australian region has so much distributed PV that we now are supplying the majority of the load in certain periods by distributed photovoltaics from very small rooftop systems of the scale of 5 kilowatts. We anticipate in the next year or two that we're going to hit periods of time where that part of the grid will be entirely supplied by rooftop photovoltaic systems. And it's only weakly interconnected to the rest of the grid. It can actually island from the rest of the grid at some times. So we're doing the work to understand how do we actually operate a grid that runs with 100% of the power very soon coming from rooftop photovoltaic systems, and looking at what we as the system operator have to do to be able to run that grid successfully. There's 3 key areas where we've been focusing our attention. The first is around the disconnection of distributed PV in power system disturbances and how we manage that. The second is around having adequate load to operate the necessary units that we need to provide all the essential system services. And the third is around our under-frequency load shedding schemes for emergency frequency control. So I'll briefly talk you through each of those. So on disconnection behaviour, this chart is showing you measurements from power system disturbances from faults that we've seen in our network. When we have a fault, it causes a voltage depression in a section of the grid. And we found that that causes a percentage of the distributed PV systems to disconnect from the system. And the amount of them that will disconnect, the proportion of disconnections, is a function of how severe the fault is. So for the most severe faults that we've seen, we could see up to around 40% of the distributed PV in a region disconnecting. And we verified this, investigated it further with laboratory bench testing of a large number of inverters that are installed in our grid to confirm that this is a response to that voltage depression. We've now built some power system models that represent this behavior so that we can study what it means for power system security. And what we found is that if we have a severe fault in certain locations on our grid, that could cause a very significant amount of distributed PV to disconnect. And that can increase the contingency sizes that we need to manage. So we normally have enough frequency reserve to manage the loss of the largest unit. We now need to manage the loss of the largest unit plus an amount of distributed PV that may disconnect in that disturbance as well. So it's increasing our frequency reserves at certain times. There's a bunch of work underway to improve the way that we're able to handle this. So we're working to improve Australian standards which apply to these small-scale rooftop systems to make sure that they've got appropriate testing for voltage ride-through behaviour, because very soon our grid will reach the point where if we keep installing PV with this behaviour, we'll no longer be able to supply enough frequency reserves to manage the extremely large contingency sizes. We've also accelerated the take-up of that voltage ride-through testing in the South Australian region because we do have a particularly large amount of PV in that region. We're working to improve compliance with those standards. We've got evidence that up to around half of the systems that have been installed in our grid don't appear to be installed on the correct settings. So even if we did improve the standards, it's not necessarily the case that they would be installed correctly with those standards. So we're working to improve those compliance and auditing processes as well. And we're working with our distribution network service providers, our distribution grid operators, on their connection requirements to make sure that the medium voltage systems they're connecting, the additional central protection that they're adding isn't causing disturbance ride-through issues. We're also working on a new interconnector to connect the South Australian region to New South Wales, because it's extremely difficult to run a grid with 100% of the power coming from rooftop PV with no units online. And we are in a situation at the moment with just one interconnector that we can lose at certain times. So a second interconnector will be very important to help run the South Australian grid in future. And we're working through improving our network constraints so that when we're in high risk periods, we can ramp down the flows on the major interconnectors and make sure that if we lost the interconnector, we would be in a secure, or we would not see a cascading failure following that event. The second issue that we've been looking at is simply around having enough demand to keep online the minimum units that we need, the large synchronous units, to supply all the essential system services. So we need a certain number of big units online to provide system strength, inertia, frequency control, and voltage control in particular. This figure here is showing you the range of load that we need in that South Australian region to keep on the minimum units that we need to supply the combination of services that's necessary. Some of those unit combinations involve much larger units, and we need up to about 500 megawatts of load. Other unit combinations have much lower minimum loading requirements, and we could get down to about 200 megawatts of load. But as load starts falling into this range, we're losing combinations of units. So we're losing flexibility in how we dispatch that system. And that's making it increasingly difficult, particularly when there's unit outages for maintenance or line outages or other constraints. The minimum that we've measured in South Australia most recently in spring was around 300 megawatts of demand. So we're very well down in the range where we have only a very small number of unit combinations that we can run now if we island that part of the grid in a high PV period. So to address this, what we're doing is putting in place the ability to actively manage that rooftop PV. So we essentially need to be able to turn down those rooftop systems when necessary. We anticipate doing that very much as an emergency measure. So it would be something analogous to a load shedding mechanism, except in reverse, to be shedding PV. We're very conscious that we're shedding very small customer systems, but we believe we're at the point where it's really essential that we have that capability in place so that our control room can turn those systems down if necessary. So we've been working with the distribution providers to put that in place, and that is now underway in South Australia to implement that for all new PV going in. Even very, very small 5 kilowatt systems must now be installed with the ability to turn them down if necessary. The final element that we've been looking at is around our under-frequency load shedding schemes. So these are a safety net that is used to arrest very severe under-frequency events. So events where we have multiple units tripping at the same time, or the loss of a major interconnector separating a part of the grid. For these types of very severe events, we rely on these relays in the network that will detect that severe under-frequency event and trip off chunks of load, which will help to rebalance the generation that's been lost and hopefully arrest the frequency decline before it goes into a cascading failure. What we've found is that because the rooftop PV is installed on the same circuits as the load, and those relays sit in the distribution network, that PV is eating away the load on those circuits. And when the relay trips, it detects the severe under-frequency and trips off that load. There's much less load there now, so it has much less effect in terms of arresting a frequency decline. And when it goes into reverse flows, where there's so much PV on that circuit that it's actually pushing energy back into the grid, the relay doesn't know that. It will still trip when we hit a severe under-frequency, and it will actually be exacerbating the disturbance rather than helping to correct it. To make matters even worse, we believe that very large amounts of PV will start to trip themselves based on their own internal protection in the inverter when frequency starts to drop below about 49 hertz. And that means that if we hit 49 hertz, which is where our under-frequency load shedding begins, that trip of PV will also exacerbate the disturbance and make it much harder to arrest that frequency decline. So we've now reached the point in the South Australian region of our grid where we have periods with very, very little load on our under-frequency load shedding scheme, which essentially means that that safety net is now gone in those periods. We have nothing to arrest that frequency decline when it gets into those very severe disturbances. This chart here is showing you studies that we've run looking at separation of the South Australian region if we lose the interconnector connecting to the rest of the grid as a function of the flows on that interconnector, the Hayward interconnector, and the amount of load that's on our under-frequency load shedding scheme in South Australia. And you can see this line here is showing you where the imports are equal to the amount of load. And we would fully expect that any points above that line would fail, as represented by the red dots, and they do. But we also see a very large number of risky periods and fail periods that are on the other side of that line, where we do have enough load, but because of these other effects, those scenarios are not passing our acceptance criteria. So where we also have a very large program of work underway to restore these safety nets. We're increasing the amount of load that's on our under-frequency load shedding scheme as a short-term stopgap measure. We're also looking at dynamic arming of UFLS relays. So that would have the relays that would be much more intelligent and can detect when the relay circuit is in reverse flows, and it would disarm that circuit. That doesn't bring back the load, but it does mean at least we're not tripping circuits that are exacerbating the disturbance. We've also put in place some constraints on our Hayward interconnector so that we will ramp it down when we're in periods where we know that we're at high risk with a lot of PV operating. And this is one where we've had to review the whole rules framework for how under-frequency load shedding is managed in our grid, because when the rules were developed, no one anticipated that we could see anything like this. So the rules don't make a whole lot of sense in terms of how much under-frequency load shedding we should have and how that emergency frequency response should be supplied. So essentially, there's a lot of work underway with our stakeholders on the design and implementation of these mitigation actions, and all of the analysis on this is very much ongoing. We've learned a lot through the work that we've done, and there's a great deal more to learn. So a lot of that is in investing in development of the tools and the data sets that we need, which are have been quite onerous to collect and put in place, and that work is very much ongoing. And there's a bunch of reports that you can look at if you're interested in more information. And I'm sure the slides will be supplied to you for these links. That's all from me. Thanks, everyone.
Thank you, Dr. Rees, for your presentation. We sincerely apologize for being behind the schedule and holding our speakers beyond the stipulated time. Ladies and gentlemen, moving forward, the Indian government is building green energy corridors to feed sustainably generated power into the national grid and transport it to wherever it is needed most urgently. KfW Development Bank is supporting India in the construction of these green corridors by co-financing to a large extent transmission lines and substations. I now request Dr. Jürgen Welschow, Head of Energy South Asia, KfW, to make a presentation on experience of development of green energy corridor. Over to Dr. Jürgen Welschow, please.
Yes, thank you very much also for having invited us. Just to make sure that everybody can hear me, can you please confirm?
Yes, sir.
Wonderful. Thank you also for your nice introduction. And I have asked you to share the presentation for me because we are not allowed as a public bank to use Zoom still. I'm very sorry for that, but thank you. I see it on the screen now. If you can please already move to the next slide. Yes, wonderful. So you may ask who KfW is. Just one simple slide on this question. KfW is a German promotional bank. We are a public bank. We are around since 70 years, but we are also the German development bank, a bit like Agence Française from France. And we are the few bilateral institutions who cooperate as development partners with India. So Germany and France and Japan have been selected among a few others to the bilateral cooperation in the development area. And this is why KfW is active in India since many, many years. We have, but not only in India, of course, in the whole region and worldwide, we have 80 offices on a global scale. Our balance sheet stands at roughly 500 billion euros. This is quite similar if you can compare it to the State Bank of India, which has a similar size in their balance sheet. However, we are a completely different animal. We are a subsidiary bank. We work through the private and commercial banking sector in Germany and elsewhere. And so you can't compare this. This is also because why we have only 6,000, almost 7,000 now employees. And we enjoy, like Germany, the best available long-term rating from all agencies. Our financing volume stood last year or arrived at record heights because of the Corona crisis. Not only did KfW lots to support the German economy and German enterprises who were in dire straits, but also like, for example, India with €500 million. The cooperation with India has a long history, and Germany is expected to commit every year more than €1 billion or $1.2 billion to India. And if you go to the next slide, please, then we can see, have a quick glance at our portfolio as it is now. So we are active in everything which is climate related, because this is the main focus. And the bulk of, at least the 50% of the portfolio is in the energy sector. The other part is in urban development, resilience, and mobility. And the last part, a smaller part, is in resource protection. So why energy? Energy has been, even the cooperation in energy has been extended a lot. And if you go to the next slides, I will briefly explain why. The reason for our dense and large cooperation in Germany with India is probably, among other factors, that India is first of all decisive for the climate change agenda in the next decades. And also we have a lot in common. We have embarked on our German way of our energy transition already more than 20 years ago or 25 years ago, and have gathered a lot of experience. And I gather that our Indian partners and the Indian government was quite interested to also learn from this experience. Just to give you a few figures, the average electricity production generation from renewables stood last year at slightly over 50% of total generation. So this is an immense amount, and we are targeting much more still. However, and there we come to the grid challenge. Of course, this is a challenge because our energy generation has become much more fluctuating. Right now, I just looked up the figure, we are standing at 30% of renewables because it's a windy day. However, there's almost no solar, it's gray. Yesterday, we stood at 20%. Last Sunday, we stood at 52%. And last summer, we had days where at least during the noontime, we had 100% coverage from renewables. So you can imagine that this is extremely challenging for the grid operators, both on the transmission and also on the distribution side, as we've just heard from Australia. And the structure in Germany is similar. We have 2 million small-scale rooftop installations, and much larger, also many offshore wind installations. The photovoltaics are concentrated in the southern parts of Germany, and the wind is concentrated in the northern parts of Germany. And now we are considering and have also started to construct huge connecting lines between the two, which is again an environmental and acceptance challenge in Germany. So if you move to the next slide, please. You have swapped back to slide 2, please, to slide 5. No, one before that. This is 6, yeah. So because we share so much, we have so much in common. Again, slide 5, please. Because we have so much in common, this is 7, 5, please. Yeah. Germany and India have agreed on a strategic, this is the first strategic Indo-German strategic partnership project. We have now one more in solar and another one in mobility, but this one was the first to support the GEC, India's Green Energy Corridors program, which has been at that time, that was in 2013, very ambitious. And already then, the targets for renewable energy capacity addition were quite ambitious, not as ambitious as they are now, but they were still already around. And this is why Germany committed initially 1 billion euro to support the GEC program, an amount which has in the meantime been increased to 1.4 billion euros. And this was agreed on, as you can see on the picture, on very high levels. And we have every 2 years now government consultations involving parts of both governments. And they also do monitor what we now managed to implement. And with that, we come to the next slide, please, number 6. So here you can see a map of the GEC partner states and some numbers on the financing pattern. So India distinguishes the interstate projects. Usually Power Grid Corporation of India Limited is responsible for that. Here we have a 70% loan share coming from KfW. And for the intrastate projects, so the transmission lines in the different states, we have a slightly different pattern, especially valuable for everything there we do there, and India is doing there, is a 40% grant coming from the central government, and then again a 40% loan portion provided by KfW and an equity or own contribution from the state transmission utilities in the amount of 20%. So we have, in the meantime, concluded 8 loan agreements totaling to this famous 1 billion euro, already quite a number of years ago, and another 400 million are still in the pipeline, are under preparation. So, and here you see the states, the green states. These are, comes not as a surprise, that have been the priority states identified by the government first, but also where the STUs, the state transmission utilities, showed enough interest and also plans, specific plans, to implement the green energy corridors. And these are the sunny states and the windy states of India, Tamil Nadu with a lot of wind power, for example, but also PV, and the others in the northeastern parts with a lot of PV mainly, but also a little, also in some degree also wind power. So, and if we then come to slide number 7, you can see where the implementation stands and what it's all about, more specifically. So just the overall picture is that our partner institutions are constructing more than 7,000 kilometers of new transmission lines, which is an extremely impressive figure, I think, including the installation or renewal of more than 160 substations. We have right now 123 contracts under implementation. We have disbursed already more than 800 million euros out of the 1 million. And in the case of Power Grid, again, they are responsible for the interstate transmission lines, the big ones, the high voltage lines. All components have been commissioned already, and according to what we have seen, in a very good quality and in a timely manner. In the States, the picture is a bit different. No, not different. It's different from state to state, let's say. Some of our partner states have advanced a lot, have already implemented almost everything. In others, it's more challenging, like in Himachal or in others, also for geographical reasons, for climate reasons, and many others, changes of governments in the meantime, and so on. But also there we have seen a very good progress, and overall we deem this project to be very satisfactory. And we are looking forward to come to an end in all projects and the commissioning by the end of this year. So the major impact of all of this is, of course, an efficient and state-of-the-art transmission capacity for 28 gigawatts of renewable energy. And I can confirm these lines are especially designed to evacuate and transport renewable energy. So they are connecting, for example, the big solar parks which have been developed or are under development. Next slide, please. Yeah, this is already almost my last one. So what is key to a successful implementation of such a big mega project? First of all, we need to have, as a financiers, from our perspective as anyway, quality assurance at all stages. And some means to achieve this is the benchmarking and sharing of best practice experiences between the different transmission utilities. For example, facilitated and moderated by the Ministry of New and Renewable Energies in Delhi. There is a meeting, a regular meeting with all the state utilities where they are questioned, how far are they, what are the problems, what are the challenges, what are their plans, what is the time schedules, reasons for delays, possibilities, options to accelerate, and so on. So this is closely monitored, but there's also, as said, an exchange between those STUs, which is quite helpful, we think. And then, of course, KfW as a financier and donor, donor countries institution, responsible for the implementation and also for the proper use of funds. We can offer support as required. We have also grant funds available and provide experts and consultants to help out wherever needed. What is also extremely important is in such a big project with more than 120 contracts is to have a standardized approach wherever possible. So, for example, we have more or less standardized procurement documents, which ease the evaluation and assessment, ranking, and award decisions a lot. And also the monitoring of the contracts, of course. Last but not least, and this is not always easy, we have to adhere to all international best practice, environmental and social standards. This is the same with World Bank and ADB and others, and Agence Française, of course. But sometimes there's a long way to go to achieve these and to recognize and to adhere to these standards. Again, our experts usually help out wherever needed. And we have seen some challenges in the sense of getting the right of way for the transmission lines on time, land expropriation and compensations and so on take more time. Sometimes they are legally challenged, but we are patient. And again, usually our partners get where they want to and manage to implement everything they have planned. However, sometimes with some delays, but this is, I think, in these mega projects, just the common way it is. Yeah, overall, we think the program is well on track and meets all mutual expectations. At least this is the feedback we get. Our support is very much appreciated. And we are looking forward to implement the next 400 million. For that, it still needs the central financing structure decisions and the respective budget provisions, which are still not there, but hopefully will be very soon. And with that, we could leverage another investment in the tune of 1 billion euros. And last but not least, some messages or lessons learned and takeaways from our experience with that program. If you go please on the next and last slide. Yeah, this has been mentioned before by some of my colleagues in the previous presentations. Of utmost importance is, of course, that somehow we have an overall strategic and also a timely planning, especially when it comes to the coordination between the tendering and constructing of the renewable energy plants, and the timely construction and provision of the transmission capacities. There we always face a chicken and egg challenge. Our STUs would not go ahead with the construction of transmission lines if, for example, the development of a solar park is delayed, but also investors, IPPs would be hesitating to provide offer for the capacities which were then tendered if the transmission grid is not yet there or not expected to be there in time. So this long-term strategy and concrete action are really crucial for investors' confidence. And this is why we think that the government or the state government has to play an important role in that. The transmission lines do not come all by themselves. You need the planning, you need to kickstart that, you need to communicate it, it has to be public, the studies must be available. The government's role would be to facilitate the consensus, or the STU's role, of course, the consensus among all stakeholders involved. It is extremely important, and that has been mentioned before by the other presenters, to work on the soft factors, the supporting regulatory environment, swift decision-making, and approval processes. And last but not least, we think in the case of transmission lines, which are designed and constructed specifically for renewable energy, electricity evacuation, in many cases, grant funding is needed, or at least extremely helpful to bridge the viability gap wherever necessary. And this was the case in the GEC program in India. And that was, of course, indeed very helpful. Then to apply international standards in technical terms when it comes to the procurement or environmental and social standards is of course extremely important, especially if you want to attract international funding. Without transmission lines for renewable energies, of course, is not only grant funds from case to case, but also long-term funding, because these investments are long-term and last much longer than the loans would last. But anyway, this is why we provide usually loans with a term of 15 years and a long grace period, by the way, which is necessary to cope with the long construction time. Yeah, with that, I would like to end, and I'm open for further discussions and questions, and I thank you very much.
Thank you very much, Dr. Welskopf. Moving on to our next presenter, we have with us today Mr. Francisco Boschel from International Renewable Energy Agency, IRENA. The International Renewable Energy Agency is supporting countries in their transition to a sustainable energy future. Mr. Boschel will put the spotlight on innovation for the integration of high shares of valuable renewable power. Mr. Boschel, the floor is yours, please. Thank you very much. And thanks to the International Solar Alliance for inviting the International Renewable Energy Agency, IRENA, to present at this important virtual event our work on innovation to integrate variable renewables in power systems. So let me start just putting
some context that in the energy transition, thanks to the strong competitiveness of renewable energy generation technologies, we are seeing now a transition toward high shares of especially variable renewable energy, so wind and solar PV. Actually, in our analysis, in a Paris Agreement aligned scenario that you can see on the screen, the global share of VRE, wind and solar, should increase from around 10% nowadays to more than 60% by 2050. With an installed capacity for PV, just looking at PV, of close to 9,000 gigawatts by the mid of the century. So just to put this in context, the total electricity generation capacity of the world nowadays is around a little bit higher than 7,000 gigawatts. So we expect to see by 2050 more PV installed than what we have totally installed in the world for electricity generation nowadays. So that's the magnitude of the energy transition we're seeing and the role that PV will have in the world. Now, to illustrate this renewable electrification trend, let us look at our projections for India. So what you can see on the chart is our analysis that indicate that the electricity demand in the final energy consumption, the share of electricity in final energy consumption will increase from around 4 exajoules in 2016 to almost 20 exajoules in 2050. So that means that the share of electricity will increase from just 18% nowadays to close to 50% in 2050 in India. And this is aligned with our global trends, where we see that today only 20% of whole energy is coming from electricity in the world. The other 80% is direct combustion of fossil fuels, but we expect that more than 50% will be electricity globally in 2050. And we see already that this electrification trend is going forward in India with very big progress, already 100% rural electrification rate achieved in November 2018. At high voltage level, the government of India has also supported greater interconnections. We just heard from KfW about the green energy corridors. And actually this week we learned that in the national budget for the new fiscal year, a new 3 trillion rupees scheme, or around $42 billion is put in place to help power distribution companies upgrade their infrastructure. So India is fully on board on this electrification trend. And within the electricity sector, the role of wind and PV, so variable renewable energy resources, is becoming more important globally as well as in India. What you can see on the left chart is the country currently has more than 80 gigawatts of wind and PV capacity installed, and we expect in IRENA that this would increase at least sixfold in 1 decade, so more than 440 gigawatts by 2030, and more than 1,500 or 1,400 gigawatts by 2050. So in terms of the share of wind and PV in total electricity generation, so the chart on the right side, it shows that in 2019, the share of VRE was around 7%, and we may see an increase by 2030 to achieve close to 34% and more than 50% by 2050. So this is again very much aligned also with the global trends that we see, where as I mentioned before, we expect more than 60% of VRE penetration globally by 2050. Now, the question is, okay, is it possible to integrate so high shares of variable renewable electricity in power systems? I remember a decade ago, countries were saying, oh, more than 10% of wind and PV, it's a huge problem, grids may collapse, and so on and so forth. But actually, for example, the current pandemic situation has shown us that actually it's possible to reach very high shares of variable renewables and keeping the power systems reliable and affordable. What you can see on the screen is the example of Europe. Where you can see that during the pandemic period, the share of renewables has reached 40%, which is 5% higher than in the pre-pandemic year in 2019. And while renewable share is increasing, we can see also that coal, gas, and nuclear generation has declined. So we see that we are getting more and more experience on how to operate power systems with high shares of variable renewable electricity. One of the key lessons that we have learned is that, as was discussed in the previous discussions, is the issue that we need these more flexible power systems to accommodate this variability. Now, traditionally, this flexibility was mainly coming from the supply side, so variating the supply from the power plants. But now we see that this variability may also come from the demand side and even the transmission and distribution systems. So our member countries have requested us guidance on what are those emerging innovations that can help them to integrate or make power systems more flexible. And as a response to that, we have done a project the last couple of years to map all the emerging innovations that may have a big impact in increasing the flexibility of power systems to integrate more VRE. And we have identified 30 concrete innovations that you can see on the screen that we consider will have a big impact on increasing the flexibility of power systems. And the first thing that is important to mention is that these innovations include several enabling technologies in digitalization, power-to-X, future grids, but also include many innovations in other dimensions apart from technology. So we also need innovations in business models, such as peer-to-peer trading or aggregators, in system operation, for example, about advanced weather forecast, dynamic line rating, and also innovations very important in market design and regulation, including dynamic tariffs, market integration of DRE, or new ancillary services that were mentioned in the previous presentations. As an output, we have this toolbox where we have all these 30 innovations mapped and explain with case stories how these 30 innovations could be implemented in different country contexts. Now, a second aspect to highlight is that each one of these innovations will have very limited impact if they are implemented in isolation. To exploit the full potential of these flexibilities, these innovations need to be combined. For example, if we look at distributed energy resources like electric vehicles, if we would like these batteries on wheels to provide flexibility to the grid, of course, we need the electric cars, but that is not enough. We also need the digital technologies to enable the communication between the power system and the electric vehicles, the charging stations, but also we need the business models like aggregators to enable them to cluster enough capacity to be able to then provide these services to the grid through innovative ancillary services and so on and so forth. So the approach is combining innovations across technology, business models, market design, and system operation to create the tailored flexibility solutions for the country. This is what we call the systemic approach. And the third point to mention here is the assessment or the evaluation on the cost benefit of implementing these innovations. It was mentioned before, okay, but what is the cost of integration? Of course, this really depends on each power system. But what we can see on the screen is that on the x-axis, we have the potential to increase flexibility of the different innovative solutions. And on the y-axis, we have the cost associated with implementing such a solution. And what we can say from this chart is that the first step is to unlock the flexibility potential that is already latent or existing in the system, but constrained due to traditional market design rules or system operation approaches. And after we unlock this potential, the next step would be to assess the new investments for additional flexibility, such as storage or hydrogen production for long-term storage. So first, let us adjust the market and the system operation to unlock all the flexibility that is already latent or potentially available in the power system, and then let us consider the new additional investments that might be required. And as previously mentioned, all this information is publicly available. We have 30 documents explaining each one of these innovations and how they can be used and tailored for each country context. We have already done some analysis for the country context in the case of India, and we have also done it for some other countries that have requested us to do so. The link to download all this information is available on the slides that I hope will be shared with you. And with that, I would like to conclude again by thanking the International Solar Alliance for inviting Irina to present. Thank you so much.
Thank you, Mr. Borchell. With this, we come to the last presentation of the day by AFD. Mr. Kedar Sawant, in charge of energy in AFD, would be making the presentation, and Mr. Sawant would share the AFD's value offer for grid integration projects. Over to Mr. Sawant, please.
Yes, hello. Thank you very much. Am I audible, Mr. Mega?
Yes, please, you are.
Okay, I will just upload the presentation. Is it visible now for everybody?
Yes, please, you can, yeah, you can make it full screen. Yes.
Thank you. Sure. Okay, thank you very much. First of all, thank you very much, Aiza, for giving me the opportunity for presenting the grid integration project and how AFD is supporting the grid integration, especially in the India as well as in the other countries. So myself, Kedar Sawant, I'm the project manager at the AFD. So as per the agenda, like as per the portfolio of the AFD, I would like to say that we have established our organization in India in 2008. It is 75 years old organization, and it is a French development agency, Agence Française de Développement, and it is a bilateral development agency of the government of France, fully owned by the government of France. And in India, we have committed over 2 billion euros, which is equivalent to the 17,000 crores. So out of which 98% are ODA compliant loans and 2% are grant, you can see. And there are 4 axes of intervention: sustainable transport, sustainable energy, biodiversity, as well as water rejuvenation and water treatment solutions, the sector for the water treatment solutions. So the next slide is like most of us, like most of the experts right now, they have mentioned about the green corridor at the transmission level, green corridor for the evacuation of the renewable energy. So my presentation is a little bit different. It is below for the solutions below the 11 kV line for the smart grid, as well as how the importance of the integration of the renewable energy has to be taken into consideration. So all of we know about the climate change and how renewable energy is booming and increasingly becoming competitive, as well as the enhancement of the technical grid is very important in order to reduce the losses also at the distribution level. So I won't repeat the same thing. I will just go further. For the AFD as a strategy, as a globally, we are helping the transcos and discoms also in order to reduce the losses, to make them more smarter in the digital form, as well as which could allow the large power injection from the renewable energy sources, as well as the storage can be utilized. So in the transmission level, you can see in the slide like we have mentioned about the AFD tool. Same as the KFW has already financed the project in India. So we have the other projects in all over the world in order to evacuate the energy generated from the renewable sources. So these tools come with the sovereign and non-sovereign loans, and with the implementation of the SCADA or the ERP systems. At the distribution level also, like we provide financing for implementation of the smart meters or distribution management system, as well as the huge underground cabling modernization, and also dedicated solutions for the renewable integration of the system into the adoption of the renewable energy in the system. So the next example is this value offer, as we are the financing agency. So I won't go that much technically on the technical terms. I will just focus on the financial terms, like as we can provide long-term concessional loans for the public discoms for the distribution level in order to make them more smarter in order to have the integration of the renewable energy. Or we can work with the CTU like a power grid or state transmission utility in order to evacuate the renewable energy from the sources. So these loans can be the sovereign loan with the discoms, state discoms, and there could be sovereign or non-sovereign loan for the CTU, which is the power grid in India. We can provide the long-term loans with up to 20%, including 5 years of grace period. And we can provide the loan in the euro as well as USD. So loan amount you can see is from the 700 crores to the 1700 crores in the one chunk. As we are not a commercial bank, we are not supposed to compete with the commercial bank according to our mandate and the ODA mandate, which is totally in line to be with our agency's mandate, as well as that we have to follow the climate change COP25 mandate also, and the project financing should go along with the gender approach, environmental, social methodology in order to have the sustainable progress in the countries where we are intervening. So, so we provide technical assistance for conducting the pre-feasibility studies or any kind of DPR preparation, as well as capacity building with the focus on. It's, as I mentioned, the gender, which is one of the important aspects that we would like to incorporate in our loan, in the loan financing. And also we can help out the beneficiaries of the loan in order to get them the sharing of the expertise and the sharing of the knowledge. They can do it with the other European or the developed country partners. So, for example, also for the innovative kind of project, we can also bring the investment grant from the various sources. For example, GCF, Green Climate Fund, or the other development funds, and which will eventually reduce the cost of borrowing for us. So, for example, this is the one of the project we started in 2016-17. We were in a contact with the Madhya Pradesh, the holding company of the Madhya Pradesh discoms, and then we have hired a consultant in order to find it out what are the different investments which can be done in Madhya Pradesh, and also on the basis of the technical viability or technical gap which was present in the state of Madhya Pradesh, and how the grids can be enhanced and how the losses can be reduced. Also, like how the renewable energy can be more injected in the distribution grids. So we hired a consultant. Then after, the French electric company has signed the technical cooperation with the Madhya Pradesh Discom and address the pilot project in Bhopal and Jabalpur for the AT&C losses reduction, as well as to integrate the renewable energy. This is one of the smart grid project that we have in the Bangladesh. Because of the time, I will just skip it. And as we can see, as smart grids, like on both the sides, transmission as well as distribution side, we can finance this kind of project. And we can always have the availability of the technical assistance sources, as well as the funding from the other development agencies in order to provide the economical as well as long-term loan financial mechanism to the beneficiaries here in India. For example, the several discoms, as well as the power grid for the evacuation of the green power from the sources itself. Okay, thank you very much for your attention.
Thank you, Mr. Sawant. With this, we move on to the country intervention segment. And as per the information I have, I would invite the national focal points of the ISA member countries in the alphabetical order to make the interventions, please. First of all, I would like to invite His Excellency Mr. Mahendra Sharma from Guyana to kindly make the intervention. Over to Mr. Sharma, please.
Megha, he has left for another meeting, so
sure, sir.
Charge d'affaires Guyana embassy is there. High Commission is there. If she can intervene.
Sure, sir. We request Her Excellency from Guyana to kindly intervene. Sure. Sir, with your permission, can I move forward?
Yes.
Sure, sir. Thank you. We would like to invite His Excellency Mr. Tawfiq Sufin from Yemen to make the intervention, please. His Excellency Mr. Tawfiq Sufin from Yemen. Sure. We'll move forward. I would like to invite Mr. Zakari Abdal from Niger to kindly make the intervention, please.
Bonjour. Donc, nous remercions Lisa d'avoir organisé donc, cette vidéoconférence sur l'intégration des énergies renouvelables. Donc, vraiment, nous disons merci. Et nous remercions aussi les présentateurs donc, qui ont présenté donc, de belles présentations. Et malgré cela, donc, nous avons quelques questions. Donc, là, des questions où nous voudrons donc avoir des clarifications sur ces derniers. Et donc, ma première question, donc, c'est sur pour Ashok-Pal. Donc, vous avez dit, donc, vous avez donc des sources d'énergie renouvelable donc en Inde. Donc, avec l'avancée donc de la technologie et du solaire, nous voudrons savoir donc parmi les sources d'énergie renouvelable, lesquelles donc vous défavorisez en faveur des solaires. Donc, ma deuxième question, c'est au niveau des Green Energy Corridor, les GEC. Vous l'appelez Green Energy Corridor. Est-ce que donc, dans ces corridors, c'est seulement donc, les énergies renouvelables qui transitent ou bien donc, c'est avec les autres sources? Ma question suivante, c'est sur les technical impacts of solar PV. À ce niveau, donc on a vu donc vraiment donc l'insuffisance donc des comment est-ce qu'on appelle des PV. Et je voudrais savoir à ce niveau, est-ce qu'avec l'avancée de la technologie, toutes vraiment ces insuffisances ont été donc vraiment donc résolues. Donc ma question suivante aussi, c'est pour Mandra Agrawal, donc qui parle aussi, comment est-ce qu'on appelle, sur les Green Energy Corridor. À ce niveau, donc, il disait en Allemagne, donc à midi, ils arrivaient donc vraiment à consommer uniquement les solaires. Donc, est-ce à dire donc avec les stockages de la nuit, en se balançant, ils peuvent vraiment donc faire cet équilibre avec les éoliens aussi. Et donc, il y a pour les Kedar Sawant de l'AFD, il dit ils ne sont pas donc des concurrents pour les banques. Je voudrais savoir, est-ce à dire ils ne prenaient pas donc d'intérêt en empruntant au pays? Donc, je vous remercie. Merci.
Thank you, Your Excellency. Thank you for your intervention. I would like to now invite His Excellency Mr. Krishan Kumar Singh from Trinidad and Tobago.
Thank you very much, and thank you for the very informative presentations this morning. They in fact highlight some of the challenges that we here are facing in Trinidad and Tobago, along with some of the recommendations that have been put forward in the presentations of how we can overcome those challenges. It's very welcome for us at this stage of our renewable energy penetration in the national grid. However, if I could be so bold to suggest maybe in the next series of webinars that some more examples from small island developing states with the experience, the demonstrated experience for renewable energy penetration, if they can present from their experiences and their challenges, I think that will do a lot for us here. But we are proud and privileged to be part of the ISA, and we are benefiting from these webinars, and we thank you very much for the continuing series and look forward to participating in more of them. Thank you very much.
Thank you, Your Excellency. Thank you for your intervention and your suggestion. Moving on, I would now like to invite His Excellency Mr. Abdi Fateh Abshir from Somalia.
Megha, I think he's also disconnected right now.
Sure, sir. Moving forward, I would like to invite His Excellency Mr. A.K. Arshi from Kiribati.
I think he's also disconnected right now.
Sure, sir. I would like to invite His Excellency Mr. Desh Sahai from Tonga to kindly intervene, please. Your Excellency, Mr. Desh Sahai. With your permission, sir, I'm moving forward. I would like to invite His Excellency, Mr. Abdoulaye Sow from Guinea.
Megha, Mr. Saw and next Ms. Radhika both are also now not visible. You can call from Burkina Faso.
Sure, sir. I would like to invite His Excellency Mr. Traor Amadou from Burkina Faso. So I think, sir, we should move.
His Excellency, NFP India, Mr. P.C. Mithani is there.
I would like to invite His Excellency Dr. P.C. Methani from India to kindly intervene and make his intervention, please. His Excellency Dr. Methani, I request you to kindly make the intervention, please. Gyani sir, do I have your permission to move forward, please?
I think also he is busy somewhere. He's not trying to.
Sure.
Not able to unmute.
If the panelists could answer the questions which were raised by the parties during the country interventions. A few questions asked by one of the participants in the country interventions, if they could be answered by our panelists.
Megha, let's continue. I'll try to answer some of the questions. There's just one person raising question. Yeah, please continue for the other interventions.
Thank you. Thank you so much, sir. With this, we conclude the country intervention segment of the webinar. And may I now request Mr. Arun Mishra, Senior Advisor, International Solar Alliance, to please provide the concluding remarks. Over to Mishra, sir, please.
Thank you, Megha. Thank you, all our esteemed presenters. We had some very good presentations on this very important topic. Grid integration is something which we generally have been bothering not only countries which have which have gone ahead with very ambitious and expensive RE programs, but also with the countries who are still to embark on this particular path. Yeah. So far, our systems have been very stable. It's a combination of fossil fuel and hydro. And in both the cases, the generation can be predicated, it can be timed, and you can know exactly how many units will be produced at what point of time. And the world as a whole was very comfortable with, a day before kind of a presentation and calculation. We knew that in case we were able to follow this particular system, hydro being the balancing thing, grid will be stable. There won't be any insecurity for the grid. We shall be able to maintain the frequency levels. We shall be able to maintain the voltage level, and there won't be any problem. But everything changed after first wind came in and now solar. No one anticipated that solar and wind will become so crucial in our scheme of things. They will come to acquire such an important place in the scheme of energy distribution in the world, not only in a particular country, but in the world as a whole. And then, of course, the climate requirements are also very pressing. So it's not only that the things are changing globally now, but also it is also definite that the projection for 2030 and 2050 very clearly say that not only interested countries or participating countries, but every single country in the world will have to go to the RE area. We just heard Irena making projections about what is the likely of RE contribution to the globe in the periods 2030, 2040, 2050, and they saw a phenomenal growth. So understandably, both these generators, whether it is wind or it is solar, the very kind of say uncertain and undependable. We just heard one presenter mentioning one solar eclipse causing a loss of 12,000 megawatts of generation in India. So that is the kind of fall that you can have. And of course, they also showed the presentations in which it's so difficult to predict how wind will behave, what kind of generation a wind energy system can contribute. So obviously, big challenge. If it's a huge production of multi-thousand megawatts of capacity, it can really impact the grid. But again, we have a wonderful presentation from Australia, where Miss Jenny Rich mentioned that they have a small part of Australia in which the total capacity of energy that is required in a particular area, almost 70% of them come from rooftops. You cannot have a more decentralized system of power supply than 70% of it coming from rooftops and likely to go up to 100%. So on one side, you have megawatt, gigawatt size capacity creations replacing coal and hydro. On the other side, you have millions and millions of rooftop systems which are feeding into the grid system. So this is a huge, huge, huge problem. But fortunately, we had some very good presentations. The Power Grid made a presentation. Mr. Ashok Paul mentioned how India was able to build up almost like 425,000 circuit kilometers of transmission lines. How it has been able to, through its REMCs, will integrate almost like 62,000 megawatts of RE into the grid. 62,000 megawatts of RE into the grid. We also heard from Mr. Gratia from REMC how in great detail how every single point has been taken care of, how the conventional SCADA system, which basically dependent only on some kind of a forecasting model and scheduling model, has been integrated with a very advanced technology so that real-time predictions can be made. And then we also heard from Mr. Chatterjee of CRC, wherein said that a producer has been given the capacity and the power to change its supply 16 times a day. That means anyone who understands grid integration will know that if I have the capacity to change my committed supply to 16 times a day. Nothing can be more flexible than this. Imagine this used to be the case, maybe once or twice you were allowed to change, but with some kind of a penalty. Now you're allowed to do it 16 times a day. So we have examples in which we found that more than 60,000 megawatts of power has been integrated in one system. We have also examples in which we said, not to speak of Europe, of course, have been doing about 40% of total supply. We got an example of Karnataka. Karnataka, one small state in India, where 55% of the capacity is RE at a given point of time today. So we have 62,000 megawatts integration with the grid, 55% of the total supply in a small state like Karnataka being managed effectively. And then, of course, we have a system in which you can change your demand 16 times a day. So technologically, all these presentations have proven, including the presentation by the Australian Dr. Jenny, that this is very doable. Technology is not a problem. The problem is that the country will have to take a necessary decision to do that. CRC, of course, Mr. Chatterjee mentioned that what are the areas in which the government can intervene.
Kann ich jetzt nicht rangehen.
And then we had two presentations from KFW and also from AFD, which basically say that money is not a problem. And KFW mentioned about how they are working in 80 countries, and AFD, of course, also is working in almost like 72 countries. Money is not a problem, even though initially some kind of a grant support will be required. So the whole purpose of this presentation today was to say that while grid integration seems to be a very challenging, very difficult technological thing, it is a doable thing. And in many parts of the world, this is being actually implemented and being done. And finally, of course, Irena has given you several books, several you stand and what needs to be done. So this is, I must compliment all of our presenters. I must thank all of them for making this presentation, making these presentations and enlightening our members. Well, some of the questions that were raised is which energy source is the best? Will obviously depend on your country's position. If you have a large supply of hydro is very good. If you have a large supply of sunshine, solar is very good. If it is a windy country, wind is also very good. And of course, no one encourages fossil fuel anymore, unless you really need it to stabilize your grid. So you can choose depending on what kind of facility that you have in asset. I want to commit to Mr. Kishan Kumar Singh that yes, in the next seminars, we will try to integrate live examples from small island countries. I can see Mr. Ramesh Kumar and Mr. Prasad Mahapatra are here. They are the people who are organizing. They will try to integrate this requirement. We had examples from India. We'll get examples from small countries. And I think the only thing that is left for me is to genuinely thank all of you. Many people generally ask whether these presentations will be made available to our member countries. I presume we have already got permission to make most of these presentations available to our member countries. In those cases where the permission is not there, we will try to get those permissions and upload these presentations in our website so that I can make use of it. So once again, thank you very much. And once again, congratulations to the team for organizing this excellent webinar. Thank you.
Thank you very much, sir.
Yes, thank you.
Thank you very much, sir. With this, I would request Mr. Ramesh Kumar, Additional Director, ISA, to kindly present the vote of thanks, please.
Many thanks, Megha. So I think we had a very detailed and a very long webinar today. Yet another webinar today, which is a topic which is very important for a scaling of solar project, and both for the distributor level as well as for the larger level. So since we are very close to our time, more than almost 3 hours, I would briefly, formally thanks once again all the, first of all the honorable NFPs and contact points from ISA member countries for attending this webinar by taking out their time out of their busy schedule. And that shows how important the topic is. And the Honorable DG ISA, His Excellency Upendra Tripathi, sir, he has given a very, very good opening and given a various dimensions of the grid integration. Thanks to Arun Mishra sir for highlighting the important major aspects of this webinar. Mr. P.K. Mahapatra, so he has actually set the context for the entire webinar, which is very important to start the discussions. So our sincere thanks goes to Mr. Ashok Pal of he's a CGM CTO of Power Grid, Ms. Sayoni Sachdeva from Shakti for her presentation, Mr. Abhimanyu Gatia for RLDC, giving a lot of in-depth into the REMCs, which is playing a very important role. Dr. Sushant Chatterjee, I've been knowing him for many years and right from the initial stages of solar development in India. So many thanks to him for giving a very proactive dimensions on the regulations, how it can help the entire scaling of solar. Dr. Jenny Rees, very important for a very, very small area of how distributed PV management is very critical. Thanks goes to Dr. Jürgen Welschow from KfW for giving the in-depth or dimensions into the green development corridor, which covers more than 28 gigawatt and 7,000 kilometers of lines. IRENA has given a very important dimension on the innovations. Thanks to Mr. Francisco Boschel for giving those dimensions to this. Mr. Kedar Sawant has given for how the role of AFD as a financial and technical support to the smart grid management for which is very important for the integration. Our sincere thanks to all the participants, which covers more than 115 people who have attended this. So all the stakeholders and all the member countries should benefit out of this. Then sincere thanks to all the ISA colleagues and ISA IT team who has made this webinar very successful. Very appreciation goes to the entire ISA project team and the KPMG colleagues. And I would mention Mr. Hemant Agarwal, he's from the ISA, who is the backbone of the entire webinar, who has done a lot of hard work in arranging this entire presentation, and a lot of appreciation and congratulations goes to him on this. The role of interpreters is very important for such webinars. So my sincere thanks goes to Mr. Rajiv Saure and Mr. Ashwan for the Spanish and French and Spanish translation. And finally, as always, very congratulations to Megha to anchor this in a wonderful way for completing this webinar. So once again, thanks to all the stakeholders of this webinar. We take more and more feedback and lessons from such webinars and to improve to make it in the next level. We have also heard for the small island requirement, which we will take care in the next time. Many thanks to all the stakeholders of this webinar, and I would like to conclude this webinar. Thank you.
Thank you very much, sir. With this, we conclude the webinar.
Thank you.